Hello everyone, welcome to this course. We are building a full distributed microservices system using Go from scratch. Now we will work with REST APIs, RPC, gRPC, RabbitMQ, Docker and Docker Compose, and real databases like Postgres and MongoDB, and even actually Mailhawk for internal mail testing. Now, by the end, you won't just understand microservices, you will have built one yourself. So let's dive in and it will be fun. Now, for the support regarding this course, you can find the course repository on github.com/nuaiman/go-distributed-microservices. Of course, the link will be attached down below. Now, the entire finished course could be found in this main repository, but if you want to go through branch by branch, lecture by lecture, you have the option to do so. Just come to the branch switching place and switch your appropriate branch. Now, within this entire course, you will encounter various different applications that we will use, for example, Docker and Postman and so on. So whenever you encounter such an software, just pause the video and download it. And with that, let's get into the course. I am going to store all the microservices within this mother folder, which is go-distributed-microservices. So I'm just going to grab this folder and bring into my workspace. Now, inside this folder, I will have many different folders, right? Each folder pointing to a single microservice. And the first microservice would be this broker service. So I'm going to open up a terminal and I'm going to cd into it so I can initialize a new Go module inside it. So cd broker services, and in that I'm going to initialize a Go mod by doing go space mod space init, and I'm just going to name it broker. Like so. Now within that broker service, I'm also going to create a cmd/API folder. So cmd and nested within it an API folder. And then that API folder is going to contain my main.go file. So this main.go file gets package main, and we have a func main in here. Now, I am going to use chi as the router because that would help us move a bit faster. So I'm going to install it by writing in the terminal go space get space -u space github.com/ let me check. Go get github.com/gochi/chi/v5. So let's install this. Now, other than this, I'm also going to install two more packages from this chi. The first one is this middleware package. Go get github.com/gochi/chi/v5/middleware. And the third one is chorus. So we can allow cross-site resource origin, right? This one. So with all the three packages now installed, I can work on this main.go. Now the first thing is that I'm going to add a constant at the top before this main function. So I'm going to say const web port, and I'm going to give it a value of 8080, like so. Now within this main function, what do we want? Well, we have a few different things that we want to do. Firstly, I want to add a log statement here. So log.println or maybe printf. And inside of this, I'm going to say starting broker-service on port colon and a %s. And also I'm going to add a line break like so, and then the value of the %s, which is this web port. So that's what I want to print out. Now, other than this, I'm also going to add a struct before this main function, which is a type application. I'm going to name that struct application so I can attach various different things to this struct and use it in my routes and handlers and so on. But for now, this will be empty. However, within the main function, I'm going to initialize it by adding it to this app variable. And instead of this, I'm going to initialize this empty struct for now. So the way we're going to run this server is that we're going to make a server variable, and this would then point to pointer at HTTP package, and there the server http.server, like so. Now the server struct needs two very important things. It needs to know about a handler, so a router that is going to route all the requests, and it also needs to know about the port at which the server is going to listen. So the first value would be this address, which is the port number, and I'm going to add here fmt.sprintf, and using this sprintf, I can pass the web port. So I'm going to add colon %s, and %s is the value of this web port. Now, other than that, we will also need this handler, and this handler is something we're going to create shortly. So that is something we're going to add here. Now, other than that, this server on which we created this pointer to HTTP server can be listened and heard. So I can access server dot listen and serve. This handler is not letting me do that, so listen and serve. Now this listen and serve also gives me an error, so I should listen to it. And I'm going to add here fmt dot maybe log dot if error is not equals to nil. So if we don't have an error, in here I'm going to call the log package, and on that I'm going to call fatal. And I can maybe use fatal ln. And here I'm just going to pass this error simply. So that is the main file. Now the next thing is that I should create that handler thing that this HTTP pointer server requires. So alongside this main, within this API folder, I'm going to create a routes.go file, and this is package main. And in here, the function that I'm going to create would be a method of this application struct. So func routes, and as I say, this function is going to be a method of this application struct. So I'm going to attach that thing right here. So I'm going to name it app, and this would be a pointer to that application struct. Now this function is a router, is a method of this application struct. Now within this function, what do we want? Well, first let's create a router. And for this router, we're going to access chi. Now we have two chi. We want the one with v5. And there we have new router. This is what I want. And by the way, I want to also return this created router. So the type of this router is a pointer to chi.max, and that is what this function should then return. Like so. So now within this, what do we want? We want to do a few things. Well, the first is the coarse middleware that we used. I want to initialize it here. So I'm going to call this router that we just created. And on that, we have this use method. Now this use is going to take that course that we installed, and on that course, we can access this handler function. Now, this handler function then would take the course.options struct, and in here, we can specify various different options for our course. First is allowed origins. So which front end is it that we want to allow? And because we are now in development, I'm going to allow all origins. So HTTP and HTTPS, all origins. So this would be a slice of string. And there in this curly brackets, we can pass individual values. The first one is HTTP HTTPS colon double slash and then star. So anything that starts with HTTPS. And after the string, separated by a comma, I'm also going to pass a second string, which would be HTTP colon double slash star, like so. So that's for the allowed origins. Next, let's work with the allowed methods. So the methods that we want to allow. For this, we want again a slice of string. And in here, I'm going to allow get. So get methods are allowed. Post methods are allowed. Put methods are allowed. Delete methods are allowed. And the fifth one would be options, like so. After this two, I want to also add allowed headers. And this again is a slice of string. And the allowed headers would be except. So this except is a header that I want to allow. I also want authorization. Authorization. The third one is content-type. And the fourth one is x-csrf-token. Now, I'm not sure if it is option or options, so I'm just going to do a quick Google search. HTTP method option or options. It's an option, not options. All right. So those were the three. The fourth one would be exposed headers. So which header is it that I want to expose? I'm again going to pass a slice of string, and within this curly braces, the value is this link. That's it. The fifth parameter is this allowed credentials, and I'm going to set it to true. And also this max age, I'm going to give it 300. So that is all for configuring cores, at least for development. Now, after that, I'm also going to use a middleware. So I'm going to access this router.use again. Now, please remember, I installed that middleware package from the v5. And on that, I have middleware.heartbeat. Now, this heartbeat takes a path parameter, and it's going to be /ping. So if I hit /ping, I can get a heartbeat, and with that, I can make sure if this broker microservice is up and running. And so we now have our routes ready. All I'm going to do is go back to main.go, and because this routes is a function or a method of this application struct, I can use this initialized application struct, which is this app, in this handler. So I can do app.routes. And because this routes function returns this chi.max, pointed to chi.max, which under the hood is simply what this handler expects, which is a http.handler. And then that is the reason we're using chi, because chi is fully 100% compatible with NetHTTP and all its implementation. Now, at this point, what I want is when this server, this broker service server is running, and then when I make a request from, let's say, my browser to this server, I want to send some response from the server back to the client, which is the browser, right? And at this point, we are just going to send, and basically we're going to transmit all the request and response using JSON. And so we have to add a handler to this server. So the server is then starts expecting some request at certain endpoint, and then the server would send some response back. And the thing is, to save ourselves from a lot of coding in the future, what I'm going to do now is I'm going to add some helper functions. So how do we read some incoming request, and then how do we respond back to the clients in success and in error? All right. So the first thing I'm going to do is I'm going to create here helpers.go. All right. And this is again package main. And the first thing is that I'm going to create a type JSON response struct in here. Now this JSON response struct simply represents what a JSON response, so the response that should go from the server to the client, should look like. Well, the first thing is it should have a error, error over error, first of all. And this error is a type of Boolean. And I'm also going to add a JSON tag in here. And the name of this JSON tag should be error. Next, I'm going to add a message. And this should be a string. And the JSON tag here would be message. All right. And the third one is this data. So I can attach anything or leave it empty. So I'm going to use this any keyword. And the JSON tag here would be data, comma, OMITEMPTY, omit empty. So we can either add data or we can leave it empty. So that's the first thing. Now, we need three functions, one for reading request, or you could say read JSON. The other one would be write JSON, and the third one would be error JSON. So let's start with the first one, and all the three functions that we are going to create would be methods of this application struct. So func read JSON, and as I said, this function is going to be a method, so I'm going to add app, which is pointed to application. So this is the first function. We will also have two other, read. The second one is for writing, and the third one is error. Anyways, let's start with this first one, which is this read JSON. And what do we want for this read JSON? Well, the first thing is that whenever an incoming message or a request is coming to us, right? So to the server, we want to make sure that the incoming request is no more than 1 megabyte. So let's set that max bytes. And I'm going to give it a value of 1048576 maybe. All right. Yeah. Next, I'm going to access the R, so the incoming request that this read JSON is for. And for that, I should add W, which is HTTP dot response writer, and comma R, which is a pointer to HTTP dot request. All right. So these two things we must have. So with that, we have the requests, the incoming request. So I want to access the incoming request, and there the body. And on that, I'm going to check HTTP, the .max byte reader. And using on this, I can pass the W. As you can see, it requires a response writer. And it also requires the body to check, which is r.body again. And then the third one is the max number in int64. So I'm going to add int64 function in here, and then I'm going to pass this max bytes. So it gets converted from bytes to int64. And this whole thing resolves and then is resaved into r.body. Next, I need to decode this incoming request. So I need to access JSON, the JSON package from encoding/JSON. And on that, I can access new decoder. And I want to decode the r.body that I got. This then gives me the decoded value. And I can use this decoded value to decode the entire body into a single response. So I'm going to access this deck.decode. And I want to decode data. Now, what is this data that I want to decode? Well, I should accept it here right here. So data is of type any. Data can be anything. So on this read JSON, we must pass data, and then this data is what I'm going to decode into here. And you can think of it this way: in various different handlers, I might have various different structs like this. So maybe in one handler, I'm expecting just email and password. In the other handler, I'm expecting name and image, and so on, right? I can pass that struct in here, and that struct will be decoded here. And it will make sure that the JSON tags of that struct that I pass here matches the request body. Because if you know, when a client would send request from frontend to backend, they're going to send JSON request, right? And that JSON request will have JSON field like that. I hope you understand. If you don't, please rewind and listen again. So deck.decode is here, and this then gives me an error, and I should handle it. If error is not equals to nil, what do I want? I'm just going to return error. And so the return type of this function is error. And if nothing goes wrong, I just want to return nil. Other than that, I should also maybe do a separate check in here. So I'm going to access that deck again, and on that I want to access decode. And on this, I'm going to pass a empty struct. And this is the way we pass an empty struct. And I want to see if that can be extracted into an empty struct. So that is also one thing I want to check. And then this also gives us an error, which we should check. And then I'm going to check if error is not equals to io package dot eof end of file. All right. And if that is the case, I'm going to return errors. So from errors package, errors.new, and I'm going to write here body must have only a single JSON value. So if the frontend sent more than one JSON value, we don't want to accept. So that's the first function, read JSON. Now the second function, write JSON. This write JSON function should also get a few things. First of all, this w.http response writer. And it's also going to take a status, int status, because this write JSON is a function that we're going to use from the client, so from the server to send response back to the client, right? So we want to pass some status code, which is int, and that would be named status, and this should be an int. Other than that, we can also send data, which is of type any, and maybe we can send some headers, which should be ... http header, and this function might return error. So now within this function, what do we do? Well, the first thing is we should call JSON package. So JSON from JSON encoding slash JSON package, and on there we have the Marshall. And on this Marshall, I want to pass data. So the data that we are getting as a parameter. And then this Marshall gives us the data and also an error. So I'm going to write here out an error, right? And the first thing is that I should handle this error. If error is not equals to nil, I want to return error. And next, I need to check the headers also. So the headers that I have here. So what I'm going to do is if I'm going to check if the length of this headers, so if the length of this headers is greater than 0, I should add this headers to the response. So for, I'm going to use this for. I get the key and the value when I range over these headers at the first index, from the first index. All right. And so in here, I want to access the W. And on that, I want to do header.set And I want to set the maybe I should do a key in here, right? So the set takes a string, so a string function, and on this I pass the key, and that is then equals to the value. Or maybe I can just do w.header, and in here I can set the key as the this value and set the value of the key. All right, that works. And next, I also want to access w.header, and I want to set here the content type. So the content dash type, and the value of this content type would be application slash JSON. So that's one thing. Next, I want to use the w.write header, and I want to also add the status that I'm getting. And then I'm going to send the response. So I'm just going to use w.write, and I'm going to pass the out in here. All right. And this then gives me the int and the error. I don't care about the int, so I'm going to use the underscore, but I'm going to use this error so I can handle the error. And I'm going to check if error is not equals to nil. I want to return error, but if there is no error, I just want to return nil. So that is then the write JSON function. Next, onwards to the last function, last helper function, at least in this file for now, which is this error JSON. Now this error JSON should get a W, which is the HTTP response writer. It should also get an error, which is the error value, so error of type error, and status, which might be ... int. And this function then would also return an error. So I'm going to add the return type there. Now, what do we want inside of this function? Well, it's a pretty simple function. First, I'm going to access HTTP, and I'm going to set the first status to status bad request. So this would be the default status. This is what I'm going to set. Next, I'm going to check if the length of the status is maybe greater than 0, because if that is the case, we want to set the status code to the one that we are setting. If we don't get anything, the default is http.bat request, and because remember this is error response. So in here I'm going to set status code is equals to status at the status of the first index. Next, let's create a payload. So var payload, which is this JSON response struct that we created. And this JSON response struct, and what I'm going to do is I'm going to access payload and there the error, and I'm going to set it to true. Next, I'm going to access payload.message, and I'm going to write here error.error. And next, I'm going to return app.writeJSON, and this writeJSON is going to take W, the status code. It's going to take the payload that I just created, and that is it. Those are the three things that it takes. And with that, that is the end of this helper file. Next, we are going to create handlers.go file so we can handle the first route. So with our standard JSON response and request now ready, let's create a new file within this API, and I'm going to name it handlers.go. And this is also package main, and I'm going to create a function, and I'm going to name it broker. And this function is also going to be a method of app, which is pointed to application. Now this function is the function that we want to fire when we hit this broker service at /endpoint, so the root request. So we pass the W, which is a HTTP dot response writer, and also R, which is a pointer to HTTP dot request. Now within this function body, first I want to create that payload by initializing that JSON response struct. And in here, I'm going to set the error first, and that's going to be false because this function should only fire if it's a successful response. We want to set a message, and I want to say broker service is running. And next, we can just send this response. Now I can access the app, and on that I can access write JSON. And this write JSON is going to take the response writer, which is W, and it is going to take HTTP, a status code. So I can do HTTP dot status OK. And I can send this payload. Now this write JSON then gives me an error, which I should handle. And I'm going to say if error is not equals to nil, I want to send a HTTP dot error response. And in this, I'm going to pass W. I'm going to say internal server error. And other than that, I can pass HTTP dot status internal server error. And then I can return out of it. So that's the broker function. And by the way, I don't need the R, which is appointed to HTTP request. So that is one thing. And now let's try it out. So I'm going to go to this routes, and here I'm going to use router.get. I'm going to use the get first, and I want to get at /, and whenever incoming get request comes at /, I want to access app.broker. Now this broker takes a W, which I should pass, and that is it. Or maybe just add the broker. Let's do .get, and it takes /, so /endpoint, and then a function. So the function I have to pass. And then in here, I want to handle, see this is important. This should be added right in here, like so. And with that, then I can do app.broker. Right. So that's the function, and let's handle it. So let's test it out. I'm going to run this service. Make sure that you are in broker service, and I can do go space run space ./cmd /API. And it is running on port 8080. Let's open this browser, and let's go to localhost :8080. So actually you should write http :/localhost :8080. And you see error is false, and I have a message. So our service is running. Let's now add Docker support to this broker service. And I don't want to run this server by doing go run over and over again. This should run inside Docker alongside my other microservices. So I'm just going to close this running service. And within this Docker service, I'm going to add a Docker ignore file first of all. Now this Docker ignore file should ignore .git. It should ignore .git ignore. It should also ignore all .exe, so all executables. It should also ignore all log files, and lastly tmp, so all temporary files. These are the things I want to ignore. Next, I also want to add another file, and I'm going to name it broker-service.docker file. And in this Docker file, now we need two steps to create Docker images. First, we are going to build a Docker image, and then we're going to run the Docker image. So first is the build step. I'm just going to add a comment in here to signify build, and I'm going to use this from keyword. So I want to get the from Golang image, and I want to get the version 1.26 dash alpine. So that's the smallest image as, and I'm going to name it builder. Next, I want to create a working directory. So work there, and that should be /app. Next, I want to copy the go.mod and go.sum into the /, so into the app. Next, I want to run go mod download. Next, I want to copy over everything from this file to the app file, like so. And then I want to build this image. So I'm going to use run command, and I'm going to set the cgo to 0. So to turn it off, cgo and underscore enabled is equals to 0. I also want to set the operating system mode to goose, which is equals to Linux. And I'm going to then say go build -o, and I'm going to name this broker, and this should be accessible from /cmd/api. So the main file can be accessed from there. So this is the build step. Next is the running step. So another comment, I could just say run. Now, how do we run this? Again, I need from, and I want to get alpine :latest. Then I need the work directory again. Next, I want to copy, and I want to copy from the builder. And I want to copy at this /app/broker, and there, dot. Next, I want to expose port 80. So this port 80 is then exposed, and then I want to run this. So cmd, and the executable is /broker. So that is it. That is the Docker file and the Docker ignore file. Now, in the next video, I'm going to explain how we can use a Docker compose file so we can run all these Docker images together. So with the Docker file added for our broker service, the idea is that in this root level of our mother folder, we also add a Docker compose file. And the reason is, if we don't add a Docker compose file, we have to manually run each of the service one after the other, all right? Because each service would be running inside Docker, and that needs a Docker file, and we have to run each of the Docker file separately one by one. We don't want to do that. We want to create a Docker compose file at this root level of the mother folder, and the Docker compose file would then know about all the services with their Docker files. And then using that one single file, we can run all the services together. So right here, I'm going to add docker-compose.yml. This is the exact name you should add. And in here, I'm going to add services. So next line, and then tab. And the first service name is broker. Next line, tab. Now it needs to get a context, so where it is. And the context is a /broker-service. So in that place /broker service. Next, in the same level as broker, I'm going to add restart, and I'm going to give it a value of always, like so. Next, I need to do the port mapping. So ports colon, next line, tab, dash, and I'm going to add a double quote here, and I'm going to point the 8080 to the 8080 of this port of the Docker. So from physical to the Docker port mapping. So that's one thing. Next, I also want to set the deploy, and the mode here is going to be replicated, and then replicas is going to be set to 1. So that's our Docker file now. It knows of the broker service, and then we're going to add all the other services like Auth and all the other things. By the way, here I should add build like so. And all this then gets indented. All right, that is correct. And actually, this here should be just 80, because if you remember in the Docker service, we are listening at port, it's 8080. Okay, 8080. All right, next, I also want to introduce Makefile, and this Makefile will live right alongside this Docker Compose. And the reason I want to use this Makefile is simple. We can simply do make up to run all the Docker images. We can do make down to turn off all those things, and we can use all these commands easily to help us aid in the development process. And please pause the video right here and copy all these commands into your Makefile. And with that, make sure that your Docker is up and running. For me, that is the case. And in the terminal now, I need to cd ... out of it. So I'm in the root level. And I'm going to xmake and I'm going to do up. Make sure I'm not doing go run anymore. I'm just going to do make up. And that is going to build all the Docker files. Maybe in the broker service, I should just name it Docker file. Like so. So with that then, let's run this make up again. And as you can see, it is working. With that, if I open my Docker and I come here, you see Go Distributed Microservices, and in there I have broker 1, and this is running. I have an image here, and it says that it is running on port 8080. And if I go to my browser and I restart it, it still works. All right, let's get back to business. We did create a simple broker service, and now it is very important that we move to the second microservice, the authentication service, which would allow us to connect the broker to the authentication service and let us demonstrate the power of microservice moving forward. So in this lecture, we are going to move to the authentication microservice. Now, to begin with, what I am going to do is I'm going to open up my file explorer for this project, and I'm just going to copy and paste this broker service, and I'm going to rename it to authentication service so that some of the codes are already pre-written for us and we don't have to write them over again. Authentication service. Now watch this. I'm first going to grab this and drop it into my workspace. So I just have the authentication service now. That is because in many places I have this broker, which should now be changed to authentication, right? So if I come to this search and I search for all the place that says broker, like so, I get to see all these places, and all those places should now be changed to authentication and replace all. That's it. So with that, I am not going to go back yet. I'm just going to stay with however I am, and I'm going to work in here. So let's have a quick look. All this looks good. The Docker file is good, yes. Authentication CMD API, yes. Let's go to CMD. We have main and starting authentication service on port, this port. Now this, I'll change it to 8081 because that one was 8080. Broker was 8080, and I'll change this to 8081. However, inside of Docker, I am going to still keep this to 8080, right? For Docker, it will be 8080, but if I run this locally using go run dot, then it will be 8081. And other than that, no, I'll keep this to 8080 as well. All of this will be 8080. No problem. Next, let's see handlers. That broker changed to authenticate. No problem. We will keep this. Let's go to routes. We don't need this. However, also not this heartbeat, no need. However, instead of handlers, I'll keep this authenticate because we will need that pretty soon. And I'm going to change this to an underscroll. Helpers is good, routes it's good, Sol is good. So that was our first basic setup. In the next lecture, we are going to start implementing the database connection. Let's start here in the main.go of our authentication service. And the first thing is, this time, inside of this application struct, I'm going to add two entries. The first one would be a pointer to our database, and this is all caps DB, and this is a pointer to SQL package, and there the DB. So that's one thing. The next thing is I want to add models, and this is something that we have not created yet, which will be inside data package and their models. So a struct, which we have not created yet. So that is something we're going to create later. Next, we need connection to the database, right? And for that, here I'm going to import a package using underscroll. In double quotes, I'm going to write github.com/ you can install it by using go-get, but since I have it memorized, I'm just going to use it. So github.com/jackc/pgx/v5 and their stdlib, because we're going to work with SQL database, which is from standard library, which is the interface, and the Postgres driver is going to be this PGX. And currently, at the time of recording this video, PGX is the fastest and most advanced driver on the market. So I'm going to hit go run mod tidy, run go mod tidy, and that's going to fix this issue. All right. Next, we will need a function here that would connect to the database. So that would be function, and I'm going to name it connect to DB. And this function takes no argument, but it returns a pointer to SQL DB. Now, within this function, what do we do? Well, the first thing is we need a connection string to our Postgres, right? And that is usually known as a DSN. And that's what I'm going to keep in here. And I'm going to get the DSN using env. So I'm going to use OS package, and there the get env, get env. And in there, I'm going to search for DSN. So no worries, Docker is going to handle it underneath. And we're going to write this DSN in the Docker file. Next, what I'm going to do is I'm going to make a for loop here, and I'm going to retry this connection. So I'm going to make a for loop with a range of 10. So retry of 10 numbers. And within this for loop, I'm going to use this SQL package to open the database. And there, the first thing is the driver name, which is pgx. And then I need to pass the DSN, so the connection string. This then yields us the database connection and potentially an error. So let's handle the error first. If error is not equals to nil, I'm going to use log.println. And in there, I'm going to say could not connect to Postgres. And I can't write today. Or actually, I think I should check here if error is equals to nil. So if there is no error, right? And by the way, I'm also going to add a ping here. So, and db, on that I'm going to use a ping. So both of this is equals to nil. So if both of these are true, and I think it should be a double AND. So we're connected, and then I can return the db. So that's one thing. And also within this range, but after this if clause, I'm going to add log.print, and this should be println. And in there, I can say waiting for Postgres. Because if it doesn't connect here, it means we're still waiting. And next, I am going to sleep for some time. So I'm going to use time, and I'm going to multiply it using, time.second, and I'm going to multiply that to 2. And afterwards, after the for loop, I'm just going to return nil. So that's my connect to DB. Next, I also have to work on this main, because in this main, I want to connect to the database, right? So the first thing is here, I'm going to add this log statement. And maybe in here, I can add one more log dot println. And in here, I can say starting authentication service, like so. Next, I should connect to the database. So I'm going to call that connect to DB, which yields a DB. Next, I'm going to check if the DB is equals to nil. So if it is empty, which means I have a problem. So I need to do log.fatalf, or maybe just fatal. And in there, I can say could not connect to Postgres. So that's that. Next, I have this empty app initialized, which I should fill up. So there it now takes the DB, which is this DB that I got up here. And the second argument is the models. And for that models, I still haven't created it, so I'm just going to leave it empty for now. With that, I have my server created. And after I create the server, I'm going to print this log.printf. And then I'm going to just listen and serve. So that's all the things. The only point that is left is that we should work with these models. So what I am going to do is in here, beside my CMD, I'm going to have, actually beside, not inside, but beside, a data package. And in there, the first file is going to be models.go. So let's see what is this models. This is package data. And in here, I should import a few things. So I'm going to not import manually. First, I'm going to add a constant. So const that is a db timeout. So that's the maximum time I would allow my application to wait for the database to finish an operation. So time that seconds and multiplied by 3. I think that's enough. Next, I'm going to also create a global db variable here, which should be a pointer to sql.db. So with this, I can access the database functionalities. And in here, for this data package, I want a new function. Now, this new function would return all the various stuffs regarding the database functionalities that we'll have. You will see in a moment. So this will take a DB pool, so which means a DB connection, which is a pointer to SQL DB. And what is it going to return? It is going to return models. So what is this models? We're going to create shortly. And inside of this, I need to make this DB. So this global DB variable, DB, this should be equals to this DB pool that I'm getting. So in the function that I'm getting, I'm going to set it right here. So the data package can use it properly inside of it. And all this does it is that it's going to return models, and that models is something that we need to create. So let's create that. I'm going to create it below, and this is a type models struct. And in here, I will have various different data structs, right? Various different structs all listed inside of these models. For example, user is a type of user, and that is something we also have to create. So this is a model, and we can have here user, user, profile, profile. We can have all those things. And this new is just going to return these models, so we can access user or profile or authentication or whatever directly. All right. So in here, it's going to return user, and this user is this user that we're going to create. All right. So let's create that user. Inside of this data, I'm going to create user.go, and I'm just going to paste in some code. Now, if I go up, well, I have this Golang org/x/crypto/bcrypt. So I have to go to gomod and run gomod tidy. Now, you can get all this code from the GitHub repo, so don't worry. And you should be very familiar with what this is. Here I have a few functions. And first I have a user struct, which has the definition of a user, right? And then I have methods. All of these are methods that get all from the database. For example, this one is for get all. I have get by email. So like so. I have get one, update, delete, delete by ID, insert, reset password, password match, and so on. And these are simple stuff. And now if I go back to models, I hope now this makes sense. I have a new constructor function that creates an instance of the data package. And in the data package, this new function then allows us to access anything. For example, at this moment, we have user. But imagine we have more things like this, students, profile, and so many other structs. Database integrations and database operations, right? And we can access all of them using these models of this constructor function of the data package. So with that, here in the main.go, we should now initialize it. So we're going to access data package and then the new function. And that new function requires a DB pool, and we can pass that DB pool, which is this pointer to SQL DB, directly using this DB, because that DB is also a pointer to a SQL DB. So we grab the DB and put it right in here. And that is all. With that, we now have set up a Postgres integration inside of the authentication service. With our Postgres integrated inside of the authentication service, we should now integrate it with Docker. So in this lecture, we're going to work with the Docker part of our microservices, right? For this, I'm just going to close off all the things first, and I'm going to go to my Docker file. And I believe that is completely all right. So what we have to do is now that we should go to the Docker Compose and there add the image for Postgres. So I'm going to go back to my mother folder, which has all the things. So authentication service, broker service, Docker Compose, Makefile, and all those things. So I'm going to grab that mother folder and bring into my workspace now. So I have access to all the things. And let's go to this Docker Compose. And my idea is that for this Docker Compose, I'm going to do a big rewrite. The thing is, here I have this broker, and here I have the build, I have restart, I have port, and I'm going to remove this deploy. No need for this deploy. What I'm going to instead add would be depends on, and it should depend on the authentication service. So I'm going to say here authentication, right? This broker should wait for authentication service to finish, and then this broker service will be built. And in return, the authentication service will wait for Postgres to be built, and then the authentication service will be built. All right, let's see what does it mean. So I'm just going to grab this and I'm going to paste it right in here. So what's the context of this authentication? First, let's change it to authentication, and this is authentication service. And the port here should now be 8081 and map to 8080. All right. Now it should depend on Postgres, like so. Next, let's work on Postgres. So I'm going to grab that again and add it right here. So what is that Postgres? And by the way, one thing that I forgot is, if you remember here in the authentication service, we have the get env, right? Here we have the get env in the main.go of authentication service. So that DSN is also something we should add in this Docker Compose. And I'll add it right before depends on. And I'm going to add environment, and that would be named DSN. So let's add everything. The host is going to be equals to Postgres. The port number is going to be equals to 5432 because that's the default port of Postgres. The username is equals to Postgres. I'm just going to stick with Postgres. The password is equals to password. I need a database name, so DB name is going to be users. SSL mode is equals to disable. And connect, I'll need a timeout. So underscore timeout is equals to 5. So there I have my broker, I have my, I'm going to copy this name. I have my authentication, then I have my Postgres. So what's the matter with this Postgres? Well, for this Postgres, these fields are not all right. The first field is image. I'll need an image, and I'm going to use Postgres, which is 18.3, and that's the latest version as of April 2026. I'll add the restart, start, to always. And then I need to add some environments. So let me just grab this environment thing here. And the first environment is the Postgres user. And the value there is going to be Postgres, like so. We will then have Postgres password and Postgres database name. So Postgres password and also Postgres DB, like so. And the DB name is users, and the password is going to be password, like so. And other than that, I think no need for this quotes in here. Yeah, no need for those quotes. Next, I need to add the port here. So port mapping. And that would be equals to in dash in quotes 5432 colon 5432. So 5432 map to 5432. And lastly, I will need volumes. So volumes, and volumes simply means whatever you add to your Postgres, it will persist Docker restart. So Docker is going to save it inside of Docker. So for that, I need to use Postgres underscore data, which is colon slash var slash lib slash PostgreSQL, like so. And all that's left is that we add this volumes right in here. So the volumes is going to be Postgres underscore data, like so. So with that, let's give it a try. I am going to come to my terminal and I'm going to say make app, and also make sure that your Docker is running. So let's do that. Let's make app. It says Postgres data is not allowed. That is because I made a mistake. This volumes should be way back, like so. So it should be on the leftmost side. So with that, let's make up. And yes, now it is working. So I'm just going to pause the video here, or maybe not. Let's see what happens. And there we have it. Everything is running, I believe. Let's open Docker. And I see Postgres is running. I also have Authentication service and broker service up and running. By the way, you can use this Beekeeper Studio. So I'm just going to close it and relaunch it. Can I? Yes, I can exit. So let me go inside the Beekeeper Studio again. And please make sure that your Postgres is running so that we can connect to that Postgres using our Beekeeper. And in here, I'm going to use Postgres. And the connection type is Postgres, username, password, host port, localhost 5432, SSL closed. User is Postgres. Password is password. Default DB is users. And the name here, I'm going to name it go dash distributed microservices. And I'm going to test it first. It works. So I'm just going to save it. And then I'm going to connect to it. Now, if I connect to it, the table does not exist. So there is no table. And you see here, I have this query. So attached in the GitHub repository, you will see the user SQL. And actually, let's do it in the next video. Now, attached in the GitHub repository, you will find this users.sql. And this is a Postgres schema which we are going to run. And this is going to create a users table inside of our Postgres database with a pre-filled value. Because in this scope of this whole tutorial series, we are not going to bother ourselves with sign up and login. So we're just going to add a default user so that we can test login directly using this admin example.com and this password. Now this password is simply very secret. This is the password. This very secret in cryptographic form looks like this. So I'm just going to remove that. And what we're going to do is I'm going to copy it all. And we're going to go to our beekeeper and we should connect to our Postgres. And in this query, I'm just going to paste it. Then in here, I'm going to select it all and run selection. I'm going to save it and no need to save it. Now here I have this public, and if I open it, I have this user. And if I go in there, you see I have an entry. So an entry into our database. Admin at example.com, first name, last name, and all those things. All right, now let's finish up this authentication service by adding a handler, an endpoint, and a handler to this authentication service, to which we are going to make request in the next video so we can perform authentication. So inside of this authentication service CMD, I'll go to routes and I'm going to add a route in here. So it will be router.post and the post is going to come to /auth authenticate. All right. And it's going to hit app.authenticate. All right. Now this authenticate is something we have from before, but we are going to drastically change it. So let's work on that. Well, what happens when someone hits this authenticate at this endpoint? Well, the first thing, if you think about it, we are expecting an email and a password, right? So I'm going to make a type struct. So type request payload struct. And in here, I'm expecting an email which is of type string, and I'm going to use JSON tag so I can convert the incoming request into JSON. So, and there the name should be email, and also a password, which is also a string, and there I also add a JSON tag, which is password, like so. Next, I should read the incoming JSON first before I try to extract it into this struct, right? So I'm going to use app.readJSON, and this takes a W. So we pass the W. I think we should also pass the R. So I'm going to bring it back. So we can pass the R. And then it takes the request payload, right? So a data in which it's going to read into. So I should pass the pointer to the request payload, like so. And it says pointer request payload is not an expression. Anyways, this gives me an error which I should handle. But again, why am I getting read JSON takes anything, right? Let me change it to smaller r. Try the pointer to request payload. I see. The reason being, this here should be a variable, not a type. Right. So that's that. Anyways, next, if error is not equals to nil, what do we do? Well, I'm going to send app.error.json. And in here, I pass the W. The error is going to be the error that I got. And the status is going to be HTTP. And there the status bad request. Because the incoming request was bad, hence we couldn't extract into it exactly. And then I'm going to return out of it. Next, I'm just going to remove it all. So next, what do we do? Well, now we're going to access the app, and there the data, and there the user. And on that, I'm going to get a user by email. And against that email, I'm going to check that if this email exists. Because if it exists, I'm going to then check the password, which means we have a proper login or a proper authentication. So I'm going to access app.models.user models.user, and I want to check using get by email. And how do I pass an email? I'm going to pass request payload.email. Now this then gives me a user and potentially an error. And let's check the error first. If error is not equals to nil, inside of this function, I'm going to again use app.error.json. So I pass the W, I should pass the error, and I'm going to send an arbitrary error because I don't want to say exactly what's wrong. So I'm going to use errors.new, and I'm going to simply say invalid credentials. And for the status code, I'm going to use http.unauthorized. And then I'm just going to return out of it. But if we don't, actually, if we get past it, it means we have a proper user. So I'm going to now check his password. So I'm going to use user.password match, because please remember, all these functions are methods, so I can just enter the user.password match, right? So in here, I am going to pass what? Request payload.password. So this then gives me a boolean valid or maybe an error. So let's handle the error exactly the same, because I don't want to be explicit. I want to be arbitrary by saying simply invalid credential. I don't want to say exactly what's wrong. And in here, I'm also going to check, or maybe I'm not valid. Maybe I don't have an error, but I'm not valid. That's also something I want to check. Next, if I get past both of this error block, it means I have a proper user. So let's send a success response. So I'm going to make a payload variable, which is our JSON response. And in here, I'm going to set the error to false. I'm going to set the message, and I can say maybe fmt.sprint sprintf. And in there, I can say logged in user %s, and this %s is the user.email, right? A very detailed message. And for the data, I'm again going to pass the user back. So with that, let's send a success response using app.write.json, and it takes a W. It takes http.status. I think it should be status accepted. Yes. And I'm also going to send the entire payload that I just created. Here, I also get a potential error, which I should handle. So if error is not equals to nil, I'm going to use http.error. And this is going to take the W, going to take a message, internal server error, and I'm going to add http.status internal server error, and then I'm going to return out of it. So then this is the endpoint which we should hit, and then this is the handler function which we will run to see if the user can be authenticated. So with that, our authentication service is now completely done for now, alongside Postgres integration inside of the Docker. Next, we're going to work on the broker service and try to hit this endpoint from the broker service. Now, let's prepare our broker service such that we can perform action from this broker service to the authentication service. So let's add an endpoint. inside of the routes of broker service, and a handler. So I want router dot post, and the endpoint would be slash handle. And then the handler would be app dot handle submission. And this will be the only handler for now. And you will see how. So let's go to handlers. And in here, we will need a few things. Well, the first thing is that we will need a request payload. And inside of that, we will have various different sorts of request payload. So let's type them out. Type request payload is a struct. And inside of this, I will have action, which is a string. And it will have a JSON tag of action. Next, I will have few other fields here, but for now, I will just have one field, and that would be the auth payload. So let's see what that auth payload is. And this is a struct. In here, I'm expecting email, which is a string with a JSON tag of email. And of course, I'm also expecting a password. Like so. And again, in this request payload, I will also have an auth, which is of that auth payload. And the JSON tag here is auth, and it can also be empty. So I'm going to add omit empty. So just like this, I can have multiple sorts of payload type here, right? And I'm going to say when I want to perform authentication, I will say here auth followed by the auth data, like so. Later, it will all make sense when we add more fields in here. So with that, let's add the authentication here, right? But first, let's handle the submission, this handle submission. So I'm just going to grab this, and now this is known as handle submission. So within this handle submission, what do we do? Let's create a variable first, so var, and this is request payload, and this is of type request payload, right? Now in here, I need to first read the JSON. So app.readJSON, this takes a W, it also takes a R, and it takes any data. So I'm just going to pass a pointer to the request payload. This yields an error, which I should handle. So I can say if error is not equals to nil, what do we do? Well, I want to send app.error.json. It takes a W, it takes an error, and I'm just going to pass the error right in here. And then I want to return out of it. So that's the first thing. But if we get past that error check, it means we have a proper JSON. I now want to switch on this action. So if it is auth, I want to perform auth. If it is something else, I want to perform that something else, right? This handle submission is a dynamic function that can connect to various different microservices depending on the action that the user sent. So in here, I'm going to switch on request payload dot action. So I'll have the cases, and actually it should be case. Now, what if the case is auth? All right, and like so. Now, if the case is auth, I'll work with that later. But first, let's add a default. So if it is default, what do we do? So what if nothing matches the case? Well, we're going to send app.error JSON. So it takes a W, and I'm going to add a error here by saying errors.new. And in here, I'm going to say invalid action. Just like that. Well, now, what if we have auth? What do we want to do? Well, I can write it all here, but to keep this function lean, I'm going to separate it out into a separate function. So I'm going to say func. And actually, let me just grab it all. and I'll remove everything in here, and I'll name this authenticate, right? This will take a W, and it will take the auth payload, this. So it's a payload, I'm going to name it P, and this is of type auth payload. Now inside of this function, what do we do? Well, the first thing is I should use the JSON marshal to send a request from this broker service to the authentication service, right? So I'm going to use JSON.marshal indent so I can format the JSON well, and it's going to take the payload that I have, which is P. It needs no spacing, but I'm going to indent it using a single tab. So like that. This then gives me the JSON data and potentially an error, and I'm going to ignore the error. Like so. So with that, we now have a JSON data, and now we can send a request using http.newRequest. And the request we want to send would get a post method, and we want to request, because we are already within our Docker, I want to go to http:// the service name, which is authentication :8080. And the name of the handler was authenticate. So that's the address. Next, I want to attach the JSON data, for which I'm going to use the bytes package, and they're the new buffer. And to that, I'm going to attach this JSON data. This whole thing yields the request to be sent, request, and a potential error. So let's handle the error first. If error is not equals to nil, what do we do? Well, I'm going to use app.error.json. This takes a W, and it's just going to take this error and return out of it. But if we get past this error, it means we have a proper request and which we can send. So now we need a HTTP client. So I need to access this pointer to http.client struct. This gives me a client. And using this client and the request, we can now send a request and we will get a response back. So I'm going to use this client.do, and it's going to do what? It's going to do this request. This would result in a response or an error, like so. And I should handle the error first of all. So if error is not equals to nil, I'm going to use app.error.json. This takes a W, and again the error, and then I'll return out of it. But then again, I should close this response. So I'm going to use the differ, and I'm going to use response.body.close. So when this function ends, I want to close this response as well. Basically, close the entire request cycle. Next, I want to check the response, and I want to check the status code in there, right? So if response.status code is equals to http://status unauthorized, because remember we have two of those unauthorized, right? So I want to check that. Yeah, so if that is the case, I want to again use app.error.json, and in here I'm going to add W and then errors.new, and in here I'm just going to say invalid credentials. Please remember, this will be sent back to the user from the broker service. And of course, return out of it. Then again, I should add else if, and I want to check the response, there the status code, if that is not equals to http://status accepted, right? That was our success response. So if that is not the case, we have a new problem. So again, I'm just going to use this app.error.json and return, but the message here would be different. So I'm going to use error calling auth service like so. And if we get past all this, it means it was a success. So let's create a JSON response. So var response, which is a JSON response. And let's set some values in here. By using JSON package, and they're the new decoder, and I want to decode this response.body on the using this decode, and I want to decode in this response. So %response. Now this thing can give me an error and I should handle it. So right after there, I'm going to say if error is not equals to nil, what do I do? Well, I'm going to send app.error JSON. And in here, I'm simply going to pass the error and then I'm going to return out of it. And after that, I also want to check if the response has an error. And I made a mistake. They are same names, so let's change it to service response, right? Because this response should be a different name. All right, so if service response has an error, I am again going to send app.error JSON, and also I'm going to add a HTTP status code here, http.status unauthorized. Seems fitting. But then again, after all of this, we now have a proper response to send. So a successful response. So I'm going to say var payload. And this is again a JSON response. And I'm going to add payload.error is equals to false. Because if we get past all of this, it means we have a proper success. Payload.message is equals to, and I can say authorized. Next, I'm also going to add the data using payload.data, and this is equals to our service JSON, and in that we will have data attached to it from authentication service to this broker service, right? And now let's send it back to the user. So I'm going to say app.write.json, and this takes a W. It takes a http.status OK, and it's going to take this payload. And by the way, this write JSON would also yield a potential error. So let's handle that. If error is not equals to nil, I want to use http.error. It takes the W, it takes a message, internal server error, and http.status internal server error. And lastly, return out of it. So that is our authenticate function. All that we have to do is attach this authenticate function inside of this handle submission. So how do we do that? Well, it's pretty simple. Here, inside of this case auth, I'm simply going to add app.authenticate. And this is going to take the W and it's going to take the auth payload. And that auth payload can be gotten using request payload.auth. And that is it. So let's test it out. I'm going to open my, I'm going to open a terminal and I'm going to say make down first and then I'm going to make up. So we run all the services again. So almost there. And in the meantime, let's also open our Postman and let me show you how to add a request. So I have named it as test broker auth, and I need to make a post request to http://localhost:8080/handle. All right. And in the body, and make sure it's raw, we add this JSON data. So action is auth. And because we want to add a auth payload, we add a auth right here. And we add the email and the password. So very secret and admin@example.com. With that, let's send it. And it was a success. So congratulations on your first microservices communicating between each other using REST. We can now move to the third microservice, the logger microservice. And for that, I'm going to start with the docker compose.yaml file. In here, we have two images for our services, the broker and authentication, and the third is the database, which is Postgres. And now I want to add Mongo. Also, I would like to add the third image, the third microservice image, which is the logger service. So at this end, before the volume, I'm going to start with Mongo. So Mongo like so. And Mongo will have a few things. It will also have some volume to store its data inside our Docker. And for that, inside of these volumes, after the Postgres data, I'm also going to add Mongo_data, like so. Now with that, let's work with this Mongo image. Now this will get an image, and the name of the image is simply Mongo. I will make sure that I add restart to always. And then I want to add some environment. So the admin username and password for Mongo. So environment. And the name value here is all caps Mongo underscore initdb underscore root underscore username. And this gets a value of admin. Next, all caps again. Mongo underscore initdb underscore root underscore password. And this gets the value of password. So our username is admin and our password is simply password. So with the environment now set, I should add ports. And the default port is 27017, and I want to map it to the Docker port of 27017, like so. Other than that, I should also add the volume entry. So volumes, that it should get some volumes. And that would be dash Mongo underscore data. And then slash data slash lib slash db, like so. So that's the Mongo part. So I'm just going to minimize this. Next, let's just check this Postgres. Everything seems all right. And then I want to add the third service here, which is the logger service. So logger, like so. Let's give it some build value. And I think I can simply just copy this and paste it in here. Now this gets the name of logger. All right. The build is /logger service, not authentication service, and that is something we will create shortly. The restart stays to always. The port is 8082 to 8080 is good. Then I want to add some environment, and in here I don't have DSN anymore because I'm not using Postgres, but now we're using Mongo for this logger. So this gets Mongo URI, Mongo underscore URI, And the value here goes in double quotes. That should be MongoDB : // admin : password. So our username and password at mongo : w7017. Sorry, I have a 27017 /?. And I want to make sure that it is a authenticated URL. So I am going to add auth source here, auth source, and this is equals to admin, like so. Next, the name of the database is going to be Mongo _DB, and the name of the database is going to be logs, like so. And this should depend on this Mongo image. So I'm just going to add it here. And then that is all. Now I'm also quickly going to just check all the other things. Let's check this. Everything looks fine. Let's check the broker. Everything looks fine there as well. So we're pretty much good to go. So we now have our entry inside the Docker Compose of Logger and Mongo. So what I now want to do is create the Logger service folder to contain all the server initialization and handlers and all those things. So I'm just going to reveal this in the file explorer. And my project, the mother folder is Go Distributed Microservices. And in here, I'm just going to copy this authentication service and paste it back. And then I'm just going to change the name of it. So this is Logger service. And actually, I'm then going to grab this Logger service and bring it into my workspace, right? And that is because now if I come to here, and if I open my Go mod, I see the name of the module is authentication. So I'm just going to grab this name. I'm going to open up this search, paste it in, and all the places that says authentication should now say logger. And then replace all. So that was good. The next thing is to install the MongoDB package that we will need. So I'm going to open the terminal, a new terminal, and let's install the package. So I want to install go.mongodb.org/mongo-driver/v2 and hit enter. So that was done. I'm just going to close this. And with that, let's go back. And what do I want to do? Well, the first thing is, let's go back to CMD and main.go. And there are a few things that we have to change. And before I do any of those, I'm going to open up this Docker file and make sure that everything is good in here. So all this looks good, and all this looks good too. And with that, from the next lecture, we're going to work on this Logger service. So our Logger service is now prepared. Let's go back to the CMD and not really CMD. Let's go to data, and there are the models. And now the thing is, for this Logger service, we're not using database SQL, right? Because we're not using Postgres. We want to use Mongo. So a few things we have to change. Also, the other thing is this user.go is not relevant for this Logger service. What's relevant is, let me just paste it in. Sorry. Right. So these are all MongoDB functions, and they're simple functions. So update, we have a drop collection, we have get one, we do have getting all, we have insert one, we have a function to get the entire collection, and so on. And the data model is this log entry. It has an ID, name, data, created and updated. And that's all. So I'm going to go to the Go mod and I'm going to run go mod tidy. And by the way, this let me rename it to logentry.go. And this logentry.go, you can find it from the GitHub repository. So with that, what's the issue? Yeah, it doesn't know what is a client. Not a problem. Let's go to models and let's fix things here. Now for the models, right? We don't want that database SQL, like I said. So I'm just going to remove this DB timeout from here. And the client here, this var DB, this is what the client is going to be. So it's a client, and this is a pointer to mongo.client. Like so. We don't want this database SQL. Next, the new function should get a DB pool, or you can say an M for Mongo. And that again is a pointer to mongo.client, right? Now this returns all the models, and in here we assign a client. So we want to assign the global client to this M that we're getting. And then this returns, what does it return? It is going to return log entry, right? And that log entry is something we can get from the log entry that we have in the logentry.go. Now this type model should also get this log entry, which is of type log entry. So that was preparing our models and logentry.go. Next, let's go to the main.go and make sure everything is all right there. Now the thing is, this web port, I'll keep it to 880, not a problem. Now we have to change a few things. For example, this DB, which is a pointer to SQL database, is something we do not need. And instead, this is pointer to Mongo, and they're the client. Next, we have our models, which is data.models. That is fine. Next, I want to make sure to look at this main function. So first I'm saying starting logger service, and then I'm connecting to database, and then I could say could not connect to Mongo. So that is one thing. Then I initialize my application where I give the database. I also give the models, and I actually pass the pointer to database to that model. So that is something we're doing. We then start the server at some port. Then we listen and serve. And all we now have to do is make sure that we fix this connect to the DB function. Now this function is not going to return SQL database. It's going to return mongo.client. And then what do? Well, we don't have a DSN anymore. What we have is a URI. And we are going to get it from the env. If you remember, we added env to our Docker Compose. And there the env name is mongo_URI. So from there, we're going to get our URI. Next, I'm just going to remove it all and rewrite it again. So we will have a for range of 10 because we want to have retry. And in this, I'll get a context and cancel when I try to connect to, first I need to actually create a context before I try to connect to Mongo. So I'm going to add context. And on that context, I want to add with timeout. Now this context gets a context.background and then a timeout, which is 10 multiplied by time.second. Next, with this context at hand, we can now try and connect to Mongo. So I'm going to call mongo.connect. And in here, I'm going to pass options. So Mongo options, and there, this options. And there I get this client. with that, I need to apply the URI, which is the URI that I got from the env. So this then gives me the Mongo client connection, so client, and an error. And first I'm going to handle the error. So I'm going to check if error is not equals to nil. In here, I'm going to set an error first. So error is equals to maybe client.ping. If I want to ping to the client, so ctx, and then need to give the next value, which is nil. Other than that, if that is the case, so if I could not ping, I want to call the cancel function. Next, within this, if error is, actually this should be equals to nil. So if there is no error, my bad. Next, I also want to check if error is equals to nil. And in here, I want to say log.println, and I'm going to say connected to Mongo. All right. Next, I just want to return this client. Now, after that, at the very end, of course, I want to return nil if there is error. Other than that, in here, I also want to call the cancel function. And I want to call log.println. And here I can just say I'm waiting. So waiting for Mongo, like so. And also I can simply time.sleep for maybe 2 seconds. 2 multiplied by time dot second. So then that was our connect DB function, and that was preparing our main.go for this logger service. By the way, we don't need this as well. Let me go to handlers. And we are going to work on this next. Now let's finish up this logger microservice by adding an endpoint and the connected handler function whose job is to listen for incoming request and then take the data and save it into the Mongo database using the log entry. And so in the routes.go and the handlers.go of our logger service is where we are going to work. Now the endpoint is going to be /log, if I'm not mistaken. And the connected function would be app.writeLog, like so. And this is app.writeLog because the handler function would be attached to the application struct, just like this routes function. So with that, let's now go to handlers.go and create that function. So func, and this will be attached to that app, which is pointer to application struct. And the name of this function is writeLog. Now this gets a W, right? Which is http.response http response writer, and then we also get a R, which is a pointer to http.request, so the incoming request. Now this function has no return type, and in the function, what do we do? Well, before we do anything in the function, I want to create a struct which represents the data that we want to expect this writeLog to handle and listen for. So I'm going to create type request payload, and this is a struct. Now in here, we will have two simple fields. So name, which is a string, and I'll also add JSON tag, and the JSON value of it should be name. And the second one is simply data. And that is also a string, and the JSON value is their string. So that's it. Now within this function, first let's create a empty variable of request payload. So I'm going to say request payload. and this is of type request payload, right? Next, I want to read this using app.readJSON, so one of the helper functions that we have from before. And that might give me an error, and I don't want to worry about that error. So underscore is equals to app.readJSON, and I want to pass the response writer, also the request, and then a pointer to the request payload, the empty request payload that I created above. And then it will be read and pre-filled. Next, I want to create an event. So what is this event? The event is simply the log entry. So I'm going to create data, and there I get the log entry. So I want to access the data package, and there the log entry. And this log entry takes a name, and this name will be gotten from the request payload. So request payload.name, and it also takes a data. Now, please remember the ID and the created and the updated will be automatically generated. All we have to do is just pass the name and the data. All right, so for the data, we pass request data.data. Next, I want to save it. So I might get an error when I try to access app.models. And on that models, I have log entry. And on that log entry, I can call insert. And this then takes an event. So an event that I have created above. Next, I want to check if error is not equals to nil. So if I have an error, I want to call app.errorJSON. This takes the W, and it will simply take an error, and I don't want to pass any additional status, and then I want to return out of it. But if everything goes smooth, I just want to now prepare a success response and send it back. So response is that JSON response type from our helpers.go. And in here, I want to set the error value to false. And for the message, I want to set a string, and I'm going to say logged. And then I want to send this success response back. So app.writeJSON. This takes a W, which is a response writer. It takes a int status. So I'm going to say http.status accepted, and then this response. And then that is all for this microservice. In the next lecture, we are going to make sure that when we do authentication, so whenever anyone is doing any authentication, before a successful authentication, a log is sent from the authentication server to this logger server, and that is saved. And then we also want to make sure that from the broker, we can also hit this logger microservice. Now we can start at either of the two places. Either we can start at broker or we can start at the authentication microservice. So whenever someone is authenticating, request is made from that authentication service to this logger service, and something is logged. So that's one point. The other starting point could also be that we start with the broker service, so we can hit this logger microservice from the broker microservice. And I'm going to start with the first one, which is when someone is authenticating, something is logged inside of the logger microservice. So again, what I'm going to do is open up this using Rivalin File Explorer, and I'm this time going to grab the entire mother folder. So go Distributed Microservice. And after that, I'm going to go to the authentication service. There in the CMD and handler.go. Here where we have the authenticate handler, and at the end where we prepare a success JSON response and we send it back. Before we do that, I want to make sure a request is sent to the logger service as well. So how do we do that? Now I can write everything in here, but I'm going to create a separate function, which I'll call in here, just so this authenticate function is lean and clean. So let's create a function, func, and this will be a methods of app, which is a pointer to application. And the name of this function is going to be log request. And it is just going to take a name and a data, both of which are strings. And potentially it might return an error. So that's the function signature. Now within this function, let's create a variable and I'll name it entry, which this is a struct. And it will have two fields. It will have name, which is a string, and the JSON tag value here is name. And then I also want a data. And the JSON value here should be data. So now what do we do? Well, the first thing is this entry's name should be set to the log request name, right? So the entry dot name should equals to be the name that we're getting, and then the entry dot data should equals to be the data that we're getting. Now I want to prepare this entry into a JSON and send it. So I will get some JSON data, also some error, and I don't care about that error. And I want to call the JSON package, and on that I want to call Marshall indent. So I want to marshal this entry with a single tap, just for purpose of nice demonstration. And then I just want to send it. So I'm going to call http.new request. And I want to make a post request. Where do I want to make a post request? To http:// the logger microservice, name of the Docker image, at port 8080, and the endpoint is /log. So that's that. And I want to attach some data using bytes package. So bytes.new buffer. And to this new buffer, I want to add the JSON data that I created above. Now this request might yield a successful request or an error, and I should handle. So if error is not equals to nil, what do I want? I just want to return an error out of here. But if I don't have an error, I want to make the request. So I want to enter pointer to http.client. And this is then the client that I'm creating. Next, I want to make the request. So I'm going to call this client.do, and it will take the request. So this then might give me a successful response or an error. And I want to handle the error first. So if error is not equals to nil, I just want to return this error. But otherwise, I want to call differ, and I want to close this response. So response, and on that I want to call close. And actually this should be response.body, and there the close. And then at the end, I just want to return nil for error. So that's my log request. All I have to do is call it from this authenticate. So how do we do it? It's pretty simple. I just want to call app.logRequest, and this is going to take the name and the data. Now for the name, I'm just going to add authenticate, just like so. And for the data, the user that is logging in, I'm going to add his or add their email address. So fmt.sprintf, and I want to add %s logged in, and the value of this %s is the user and the user that I have and the user's email, like so. Now this log request again might throw me an error, because if you remember, it might throw an error and I should handle that. So if I have an error, what do I want to do? If error is not equals to nil, I simply want to call app.error.json, and to this I'm going to pass w and the error, and then I just want to return out of it. And that is all. That is how we send a log request from this authenticate. Now to finish everything off, we should also make sure that we can call the logger microservice from the broker microservice. So in the broker microservice, there are the routes, and actually in the handler, if you remember, we just have one single endpoint, which is the handle submission. And this handle submission has a dynamic part, right? We have an action where we can say if we want to log or we want to authenticate, and then it has various data types. So the next data type that I want to enter would be the log payload. So type, let me just grab this, and it should be log payload. And this log payload takes a name and a data. And the value there is this name and then this data, right? Now the second thing would be to add the request payload, actually add the log payload inside of this request payload. So I want to make sure this is log and this is of type log payload, and the JSON value should be this log like so. So the first part is ready. What we now should do is make sure that this, actually we don't have this broker function anymore. Oh, sorry, we have it. Sorry. So we have this broker, we have this handle submission, we have this authenticate. All we have to do is make sure in this handle submission, we now have a case for log and then a pairing function, which we will then have to create. So we will have a new case now, case log. And when the case is log, so when the action is log, we want to call app.log. So a function app.log, which we will have to create. And that function will take the response writer and the request payload of log, not auth. So like so. So I'm just going to grab this authenticate function and paste it here. And I'm going to remove everything from inside of it. Like so. This should be named log. And this expects a payload of type log payload. And that is it. So with that, let's now work with this function. Now within this function body, first we want to get some JSON data, like so. Also, we will get an error, which I'm going to ignore. So in here, I want to access the JSON package, and there the Marshall indent, or you can simply use Marshall, doesn't matter. And I want to add the payload here, then this, and then a single tab, like so. Now this gives me the JSON data, also an error which I ignored. So with this, now I want to make a request. Please remember, we are now in the broker service, right? So with this JSON data of the log payload, we now want to make a request to the logger microservice, just the way we did with from the authentication service to the logger service, right? So in here, what do I want? First, I want to make a HTTP request. So http.new request. And I want to make a post request to http:// and the name of the service is logger at port 8080/log, the endpoint. And this will take the bytes.new buffer, and it is just going to buffer this JSON data, right? Now this expression can give me the request that I am trying to build, request est request, or an error, and I should handle this error first. So if error is not equals to nil, I would like to call app.errorJSON. This takes the W and the error, and then I simply want to return out of it. But next, I want to create a client using pointer to http.client, which gives me the client. And now I want to use this client. So I'm going to call this client.do. So client.do the request. which would yield me a success response or an error. So let's handle the error. So if error is not equals to nil, I want to send an error JSON and return out of it. But in the bright side, if we have a successful response, I firstly want to make sure that I call differ response.body.close. Great. And then I want to check if the status code on that response, so response.status code, is not equals to http.statusAccepted. Please remember, from the logger service, this is the successful status we send, status accepted. So I want to check if that is not the case. So for any other case, we have a problem. So if that is not the case, I want to send app.error.json like so. And if all this goes well, it means we have a proper response. So now we should prepare a response again so we can send back to the user who's making the request. So var payload, and this is JSON response. And I'm going to set response.error to false. Then this payload dot message, and I'm going to say logged. So login worked. And then I'm simply going to call app.writeJSON, which takes this W. It will take http.statusAccepted, and it is going to take this response. Now, of course, I also get an error here, which I can handle. So I'm just going to do unused write to field error. What's this? Never mind. So if error is not equals to nil, I want to call http.error. Now to this, I want to pass W and then internal server error and also http.status internal server error like so, and then return out of it. So that is my whole function. I just don't understand what is this unused write to field error. Ah, my bad. I should name this response. Or maybe I should just name this payload like so, right? So that is the end. In the next lecture, let's test everything out. Now, let's test everything out. And make sure you do make app so everything is built and running. And what I'm going to do is open up my Postman first of all. Now, in the Postman, we can try test broker. No worries there. This should be a get. And let's try it. That works. Now let's try the test broker log. So let's just try to log without authentication. Now this will be, of course, at handle, right? And the action is log. Now inside, we need a log data, and I'm going to add a name of maybe first log. And for the data, I can say first first log data, right? And first log name. And this is a post request, and let's send it. So I see false and I see it was logged. And then let's also try to authenticate. So we know for authenticate, of course, we have the same handle at post, and the action is auth. Then the auth body is email and password, and those were the email and password. So let's send that. So please remember, we first logged using test broker log, and then we did authentication. And we know whenever we authenticate, we also log, right? So we should have two log. Now let's open up our MongoDB Compass, and you can install it if you don't have it. And then we need to add the URI. And this URI is something you can find in your Docker Compose. Now, if you paste that in, you can connect. And if you connect, you will see that you have this logs database. If we go in, we have this logs collection. And inside, we get to see first log name and first log data. Now, the other thing is this second option was also added, but no data was added because maybe we made some mistake when writing the handler. And you can try to fix that yourself. Let's start working on the next microservice, the mailer service. And the job of this mailer service is to send email. And because we're in development, a good idea is to use a simulated email service, which would allow us to test emails being sent and received and so on. Right? And for that, we're going to use Mailhog. Now, the interesting fact is that Mailhog itself is created with the Go language. Now, to get started, we're going to start at the docker compose.yaml, and here I'm going to add an image. Now, I'll name this mailer, and of course, this mailer image will need an image to pull, right? And for that, in single quotes, I'm going to use mailhog /mailhog:\latest. Next, we need to add ports. And we're going to add two sets of port. The first one is 1025 mapped to 1025. And then the second set would be 8025 mapped to 8025. So that's all. Let's now open up our terminal. And the first thing we're going to do is make down to stop any running service. And then we're going to do make up. So Docker then pulls the latest Mailhog image. And we can see it is pulling the latest Mailhog image. So let it work. And as soon as it would be done, we're going to test if the image is working properly. And with the pull now complete, we can give it a try. So let's open up our browser and let's search for localhost 8025 and hit enter. Let's just go for 1025. All right. You should have it. Let me just open up the Docker. All right, there it goes. Everything is running. Yep, here it is. Because my mailer service is at the end, first all the things from above runs, and then and only then the mailer runs. And here it is. So with our email or the mailer service image now added, we can now create a stub server, a stub microservice for the email, right? So I'm going to open the folder in Rivalin File Explorer, so the mother folder, and I'm going to copy this broker service and paste it back. Now I'm copying the broker service because just like the broker service, this email service needs no connection to any database. So mailer service. And this mailer service is what I'm going to drag into the workspace first. Now let's go back to the Go mod. And this broker, I'll change the name everywhere from broker to mailer. Like so. And with that, we have our Go and Gochi from before. All we have to do is go back Go back to CMD. Let's go to routes. We don't need this route. We also don't want anything in the handlers for the moment, so I'm just going to remove everything. And with that, we can now go back and drop our mother folder, which is Go Distributed Microservices. So at this point, with our Stub mailer service ready, we should now create a package, a file, which would hold what an email server looks like, what a message inside of it looks like, and the functions to send emails. So I'm going to open up our mailer service there inside CMD API. I'm going to create a new file and I'll name it mailer.go. Now this is of course package main, and in here I will have structs of mail and message. So let's start with the mail first of all. So type mail. What should a mail hold? Well, if you think about it, the first thing is we need a domain, which should be a string. We will need an address, which is otherwise known as host, which is also a string. We are going to need a port for this server, which would be an integer. We will need username and password, which are strings, and we might use it later if we need to authenticate if necessary. Next, we will need encryption type, which are string. Now for development, we don't want to really bother about encryption, but nonetheless, we should learn and prepare for production. The next thing is a default from address, which is a string, and a from name, which is also a string. So then that is what a mail should look like. Now let's configure the message within a mail. So type message is another struct. And what should a message of an email look like? Well, we should have a from address, so just from is a string. We will need a from address, which is another string. We are going to need to, so to who it is being sent, which is also a string. We will need subject, which unsurprisingly is another string. We will need attachments, which is a slice of string. Now, of course, in this lecture, we are not going to be bothering ourselves with attachments, but nonetheless, we should prepare for it by having an attachment slice of string fields, and the slice of string would point to the path of the stored files within your server, right? Or in some CDN. Next, we might have some data in the body, which is of type any. And then we will also need a data map, maybe for some more complex data, so for which would be a map of string key and any value. And by the way, slice of string is to be written like this. So then this is what a mail looks like, and this is what a message of an email or a mail looks like. Now let's work on the function to actually send an email. And we're going to install a package. And this is the package which would allow us to set up a server for SMTP email server. And you can get it using goget github.com/xhit/gosimplemaill/v2. We should go into cd mail service and then install it. All right, there we have it. And now let's work on the function. So func, and this function is going to be a method of the mail struct. So m pointed to mail. And we're going to name it send SMTP message. Now this function should get a message, so it is MSG, and this is of type message, and it might potentially return us an error. So let's work on this function. Now within this function, I want to check if the message has a from, or if it does not have a from, we will use the default from name. So I want to check msg.from. if this msg.from is equals to an empty string, and in this case, we're going to set the message.from. What's wrong? Just a moment. I forgot to add the if statement. Right here, right? So in this case, if message.from is empty or is equals to an empty string, so in this case, we're going to set message.from should then be equals to the mail, and from there, the from address. So the default from address of the mail. Next, we're going to do another check if message.from address is equals to empty. And if that is the case, we're going to set message.from address equals to m.from address. And this should be from name. Do we have a from name? This should have been name, my bad. Sorry, this is good as from, and this should have been from name, like so. So in here, we then use from name and then from name right here. So that is it. Next, let's prepare a plain text email. So I'm going to create a variable plain message, and I might also get an OK. So if everything is good, and I'm going to use MSG and then the data, msg.data, and here I'm going to add a string function like so. Next, I want to check if not okay. So if something is wrong, if not okay, in that case, I'm going to set this plain image, a plain message manually. And I'm going to set it to say invalid message content, like so. But if everything is okay and nothing is not okay, now we can start or set up the first SMTP server and configure it and then send the email. So we need to create a server in the server variable, and we're going to get it using the mail, not the netmail. So we should import the package that we installed. And I'm going to do that under the mail alias. So let's come up here. Let's add an import. And like so. This is what I want to add. Now I can use this mail right here and then enter into it the new SMTP client. This is what I want. So now I have a SMTP server, and now I need to configure this SMTP server. So the server should get a host, and that should be equals to m.host. So the mail.host. Next, the server needs a port, so server.port, which is equals to m.port. We will need server and there the username, and this is going to be m.username. Next, we will need server.password, which is going to be equals to m.password. We will then need server and its encryption, which is going to come from the message.encryption, but actually we are going to create a function to determine what sort of encryption we want. So I'm just going to add here m.get encryption, encryption, and this will then take m.encryption. Now you see this is m.getEncryption function because we are going to create another function which would be a method of that mail, right? And we're going to do that later. Now let's move forward. After the encryption, we want server.keepAlive. So we want the server to stay alive, and we're going to set it false. We are going to add some timeout. So server.connect timeout, and we're going to set it to 10 multiplied by time.second. Next, we want to add server.send timeout, And this is again equals to going to be 10 multiplied by time dot second. And with that, we now have our server setup and then the configuration of the server. All we have to do is now make sure that we connect to this server and then start the sending email procedure. So we want to get this server, and on that we want to connect. And when we do that, we get the SMTP client. So SMTP client, and we might also get an error. So let's handle the error first, and I'm going to check if error is not equals to nil. I'm just going to return the error, all right? But if we do not have an error, what do we do? First, we need to configure the email. So we should enter the mail from the Go Simple Mail v2, and on that mail, I want to make new message. So this then gives me an email, which is to be configured. And now let's configure it. So I'm just going to do mail or email dot. I want to set its from, so set from, and this set from gets the message dot from. All right. And additionally, I'm going to chain in some methods. After the from, I want to add the add to, so the to who it's being sent, and that is going to be message dot to. I also want to chain in set the subject, and that is going to be msg dot subject. So these three things in chain. And next, after that, I'm also going to set its body, so email dot set body, and this is going to be message dot, not really message. I want to enter the mail package, and on that I want to add text plain, and the text plain to be texted is this plain message that we created up above. All right, so that is one thing. Now we might have an error when creating the HTML message, so we should add a fallback. So I want to also make a HTML message, a fallback HTML message, and this should go in like this, double quotes, inside of that a paragraph, and then outside the double quotes I want to concatenate the plain message, and then again concatenate the ending tag. So like that. Next, I also want to enter this email, and on that I want to add alternative, and this alternative would be the mail.text HTML and then the HTML message. So if in case we fail to send the normal plain message, I want to send this HTML message. And next, let's check if the length of message and there the attachment is greater than 0. So in this case, I want to range over things. I want to range over message.attachments. I think I should first add the for loops of for, and I don't care about the index, but I get each of the file when I would range over msg.attachments, right? And I also want to add those. So email.add attachment and add those files, just like that. And with that, we can now send. So let's do email.send, and we want to send to using this SMTP client. This might yield an error, so we should handle it. And we're going to do if error is not equals to nil. What should we do? We just can return the error, and if we don't have an error, we can just simply return nil. Like so. So that is then the end of this function, the send SMTP message function. All we have to do is to set up this get encryption method for the mail struct. So let's do that. Just going to grab this part. And the name of that part should be get encryption. Now this get encryption is just going to get us S, which is of type string. And it is just going to return me mail.encryption, right? And this is a very simple function. Inside of this, we're just going to switch over the S or E. I think I should name it E for encryption, E that we get. And in here, let's add a case. So the first case is case of TLS. So if that is the case, what do we do? I just want to return mail.encryption start TLS. The next case is the case of SSL. So if that is the case, I want to return mail.encryption encryption SSL TLS. The next case is for none. So if we have a none or maybe an empty. So if either of this is the case, I want to return mail.encryption none, and then a default case. So if something we don't recognize, in that case, we're just going to return mail.encryption, and maybe I should use the start TLS, like so. And then that is the end of this mailer.go for now. So now we can set up the endpoint and the handler function to actually send emails. And we're going to start at the main.go, because in that application struct, we need to make sure that we initialize our mail, right? Because if you remember, the mail needs all these things, domain, host, port, and all those things from the env potentially. So let's do that. In the main.go of this application struct, we need to add mailer, which is of type mail, like so. And then in the main function, where we initialize the application struct, there we should then pass the mailer, which would be create mail. And this is a function which we will create soon. Now, outside that function main, let's create that mail function. So func create mail. Now it is just going to return a mail type, and it takes no argument. And first, let's set the port. So port, and I want to ignore the error. And we're going to get that using stringconf.atoi. And in here, we're going to get it from the env. So OS, so we need to call the OS package dot get env. And the name of the environment variable should be mail underscore port. So there we have the port. Next, let's set up the mail itself. So m variable, and this gets the mail struct. And let's configure this mail struct. First, we have the domain, and we're going to get os.getEnv, and in there, the name should be mail underscore domain. And I'm just going to grab this much because we're going to repeat it a few more times. Next, we would have host. So this would be mail underscore host. We will then have port. And this is mail underscore, not really mail underscore port, but the port that we created up above here. And I should have a gopher symbol right in here. All right. So after the port, what do we have? we have username, and this is mail underscore username. We will then have the password, which is mail underscore password. We will then have the encryption, and for this we will have mail underscore encryption encryption. We will then have the from name and from address. So the from name is mail underscore from name, and then the from address, which is mail underscore from address, like so. And then at the end, we're just going to return this M. So that is how we're then creating the instance of mail and configuring it to the application struct. Next, let's move on to adding a route. So an endpoint and then the handler. So it should be router.post, and this should be send/send, and the function is going to be app.send mail. All we have to do is create this send mail. So let's open up our handler, and in here, let's work on that function. So func, and this is a method of app, which is a pointer to the application, and the name of it is send mail. Now this is going to take a W, which is HTTP dot response writer, and also an R, which is pointer to HTTP dot request. And with that, let's work on this function. The first thing is that I want to add a type, and this is mail message. So what does a message of mail is? And this is a struct, MESSHE. So in here, we will have a few things. For example, the from, and that is a string. And I want to have some JSON here. Now, please remember, this is the route handler. So from when we are making a request to this mailer service, these are the data we want to attach so we can send an email, right? So in here, we will have from, we will have to, we will also have subject and message. Like so. Next, I want to create an empty instance of this mail message. So var, and this is a request payload. So request payload, and this is of type that mail message. Next, I want to read the JSON and attach everything from there to here. So here, we're going to call app.readJSON. And we want to use the W, we want to use the request, and then we want to add the pointer to this request payload, right? Now this might yield an error, which we should handle. And we're going to check for the error. If error is not equals to nil, what should we do? I want to call app.errorJSON and simply add the W and the error itself and then return out of it. And I'm just going to copy this if statement because we will need it again later. And now I want to configure the message. So MSG is a variable, which is the message struct from mailer.go. And in here, let's set the from to be request payload. And there the from, we want the to, and that should come from the request payload dot to. We will also have subject, which is request payload dot subject, and then we will have the data, which is request payload and there the message. Next, we want to send this email, right? So we want to call app and there the mailer. And on that mailer, we get the SMTP send SMTP message, which takes the message like so. Now this gets us the maybe an error, which we should then handle. And we're just going to check if error is not equals to nil, send app.error JSON and return. But then again, if there is no error, what should we do? Well, I want to call my JSON response. And inside of this, I want to set the error to false. And I also want to send the message to say sent to, and then concatenate some more data here. For example, request payload.to. So send to this. And this is my payload, right? Next, I can send a success response app.writeJSON. This takes the W and http.status accepted. It is going to take the payload, and that is it. So our mailer service is now ready. All we have to do next is add some more dependency in the Docker Compose because we have a lot of get env, which we have to configure. And then we're going to try it out. Now, before we move to the broker, to make sure that we can actually trigger sending email from the broker to the mailer service, let's come back to the Docker Compose and make sure we add all these things. So a mailer service, which points to our mailer service and configures all the environment. Now, other than that, this mailer that we added before, I'm going to change its name from mailer to now say mailhog. Mailhog, like so. And this one should then be mailer. All right? So with that, in the next lecture, let's work on the broker. Now at this point, we can move to broker and make sure we can trigger sending emails. Now before I do that, before I enter broker and there the routes and handlers, one thing again, because we are in development, we are testing if we can trigger sending emails from the broker to the mail service. But in production, you would never do that. You wouldn't allow users to trigger sending emails because all sorts of spam emails would then be flying around. Your email should only be triggered from within the microservices, not from the broker, which is connected to the front end. All right. So with that, let's go to the routes, which has this handle submission. And that handle submission has an action and then various actions that it performs. So now the next thing would be to add the ability to send email. So I want to add a mail, and this is of type mail payload. Like so. And we will also need some JSON tag. And the value here would be mail and omit empty. Like so. Let's create this mail payload now. So type mail payload is a struct. And what does it have? It has a from, which is a string, and the JSON value there should then be from. We will have to subject and message. So to subject and message, and right here also to subject and message, like so. Next, let's go into the handle submission and let's add a case for it. So if the case is mail, we want to add request payload.mail, right? And then we will also have a function, and the name of the function could then be send mail, or maybe just mail. Doesn't matter. Now let's create that function or the method of app, which is mail. So I'm just going to come to the bottom and add a new function. So let me just grab the signature. And this is known as mail, and it takes a P of mail payload, right? Now within the function, what do we do? Well, the first thing is to get the JSON data. So JSON data, and I don't care about the error. When I do JSON dot Marshall indent, or you can just do Marshall, doesn't really matter. And I want to set here the message. The P for the payload. Next, I want to add an empty string, and then I want to indent using a single tab. So like so. And then I also need the mail service URL, right? So as URL to the mail service, well, but it doesn't matter. What I then want to do is call the HTTP dot new request, because I want to send a new request to the mail server. And this is going to be a post request. And then the URL is mailer colon 8080/send. Right? The name of the service is mailer at port 880, and the endpoint is /send. And then I want to call bytes package, and then the new buffer to buffer this JSON data. Now this then gives me a request and potentially an error. So let's handle the error first. If error is not equals to nil, I'm going to call app.error.json, add the W there and the error itself, and then return out of it. And I'm also going to copy this error because I need it again, I know. And then I want to call the request.header. And there I want to set the content type. Now it's a good practice, but you don't have to do it necessarily. So content dash type, and its value is application /JSON, like so. And then I should call the client, or I should create the client variable, which would be pointer to my HTTP, and there the client. Next, I can call this client to do the request. So client to do. And then in here, I'm going to pass the request that I created above. Now this then gives me the response and an error. And I'm going to handle the error just like that. And then I should also differ close the response and there the body.close, like so. Next, I want to check the status code of the response. So if response and there the status code is not equals to http.status accepted, because please remember, when the response is successful, we send status accepted from the mail service, right? So if this is not the case, I again want to send an error JSON, app.error.json, and in here I need to pass the w errors.new to create some errors by myself. And in here I'm going to say error calling mailer service. And of course return out of it. But if we don't have error, I want to create a JSON response, so var payload, and this is of type JSON response. And in this, I want to set the payload.error to false. I also want to add a message, so payload, and there the message should then be equals to message sent to, and I want to add the message and there the to, so the p.to, and then send a success response. So app.write.json. This takes the w, it takes http.status accepted, and it also takes the payload. And then that is it. By the way, This request header set content type, I'm going to add it for all the functions above. Like so. It's a good practice, so we should not ignore it. And that would be all. And so let's test it out. Let's test triggering email from the broker to the mailer using HTTP request. So I'm going to open up my terminal and I'm going to do make down. And then I'm going to do make up. We have an error here in the Docker file and it says mailer mailer-service.docker file. So let's open the mailer service. Let's go to Docker Compose and let's see the context of this. So this is just context./mailer service. So for the mailer, I just want to add a context, not the Docker file itself, because Docker file would be found itself. And then this is mailer service. So with that, let's try it back. I'm going to do make down and then do make up. That looks about right. Just a moment while it initializes and boots up. And in the meantime, I'm also going to open up Postman and clone a request. So here I have test broker auth, test broker log. Let me duplicate this test broker log and I'm going to rename it to now say test broker mail, right? And in the body, the action is mail. And in here, this is also mail. Now it will need from, it will need to, it will need subject and message. From, to, subject, message. Now the last one won't have a comma. So we have the from. We need to, we need subject. We also need message. So from could be boydetik@gmail.com to John Smith, right? Maybe johnsmith@gmail.com. We want the subject, first log, first mail, and I can maybe say first message and try to send it. So we have another error here. Let's go back to the handler, did the mail, and that all looks good. And the error seems to be in the handler. If you notice above, for the log, we have http://. We don't have it for the mail. So let's just add that. And with that, let me open up a new terminal and do make down. And then we can do make up. So wait again a bit for the Docker to boot up all the containers. And with that, let's open up our Postman and send the email. And that was a success. So it says message sent to johnsmith@gmail.com. And by the way, I'm also going to open up this browser and go to localhost 8025. And in here, you see, we have an email from poidutik@gmail.com. Amazing. Onwards to RabbitMQ. And in this section, we are going to add the RabbitMQ database, and we're going to create a listener service using AMQP, Advanced Message Queuing Protocol. And the idea is that from broker, every action would be logged into the RabbitMQ database, and the listener service then would listen for what to execute. Now, I highly recommend that you get the updated Docker compose.yaml from the GitHub repo, because in here we now have this RabbitMQ. We also have the listener service, which we're going to add soon, and a bunch of changes. For example, this mailer now depends on RabbitMQ. The mail hog doesn't, Mongo doesn't, Postgres doesn't, Logger does, as you can see. Authentication doesn't, broker does. So for all these additional changes, I highly recommend that you go to the GitHub repo and get the latest docker compose.yaml. Now with that, let's create a new listener service, and I'm simply going to make one here. Now inside of this listener service, I just want to have CMD, and from the broker service, I'm going to get this docker ignore and docker file and paste it in here. Now for this docker file, I just want this /cmd because I don't have a /API. And all the place that says broker should now say listener, listener, right? Like so. And so let's open up our terminal. Let's go to cd listener service and let's initialize a Go module. So go mod init listener, listener. So that's done. Other than that, we should also install this go get github.com/rabbitmq/amqp091-go. So that is all is done. Inside the CMD, let's create a main.go, and this is package main, and a func main. Inside of this, I'm just going to add fmt.println listener, just for now. So with that, inside of our terminal, let's go cd ... to go one folder up into the mother folder, and first let's do make down, and then make up. So this should start building. And in the meantime, if we go back to docker compose.yaml and there in the RabbitMQ, you see we are using the RabbitMQ for management image. And management gives us a web console to see all the things, right? Just like the mailer. The mailer had a mailhog had a web console where we can see the received emails. Similar to that, we can also have a console for this RabbitMQ. So this is the port. And if I open up a browser and go to localhost :15672, here it is. Now back in the Docker Compose, you see we have an environment for admin and password. So username and password. So let's enter those, admin and password. And if we log in, here is our console. Let's try to connect to RabbitMQ. And I'm back inside the main.go of our listener service inside CMD. And in this main.go, we need to perform a few things. Let me write those in comments. So try to connect to RabbitMQ, possibly with retry. All right. The other thing would be to start listening, listening to messages. We need to create a consumer, so create consumer. And finally, we should also watch the queue and consume using the consumer we created. So consume events. So these are the things we have to do. Now, the first important thing is to create a new function that would allow us to connect to RabbitMQ. So I'm going to create func connect to RabbitMQ, all right? And this function takes no argument, but it would return two things, a connection to RabbitMQ and an error. So to return the connection to RabbitMQ, I should add an import line, and I'm going to add an alias to it, AMQP, and the alias goes for github.com/rabbitmq/amqp091-go. All right. So in this function, the first return value would be a pointer to AMQP, and there the connection. And second one is a potential error. Now inside of this function, we are going to start off with three variables. The first variable is the number of retry iterations. So first iteration, second iteration, third iteration, or first retry, second retry, third retry, right? So var count, which is an int. The next one would be var backoff. So for example, if we fail to connect in the first iteration, for the second iteration, we're going to wait a bit longer. For the third one, more time. For the fourth one, a bit more time, all right? We want to increase the duration of our wait for each retry. So that is our backoff. And this would be equals to 2 multiplied by time dot second. And next, I want the connection. So var connection. And this is then same as pointed to AMQP dot connection. All right, so now let's work. The first thing is I want a forever for loop here. All right. And inside of this loop, I will try to connect and wait, try to connect and wait. So let's first try to connect. I'm going to use that AMQP, and on that I have this dial method. Now this will take the URL of the connection, but please remember in our Docker Compose, we have env for this listener service, because this main.go is the listener service. So for this listener service image, we have environment. And then this is the URL that we want. So in the amqp.dial, we want to use OS package. And there the get env. And in there, we can write the name of the environment variable, which is AMQP URL, like so. This would then yield a connection or an error. Or I can just say C for connection. Now, first thing is first, I should handle the error if error is not equals to nil. If that is the case, first I want to add a log.println. And in here, I'm going to say RabbitMQ not ready yet. And then I want to call the count. And I want to add one to it. Else, if that is not the case, I want to call log.println. And in here, I'm going to say connected to RabbitMQ, and then create the connection. So I need to call this connection variable and put that equals to C, right? And then break out of this loop. So that's the if else. After the if else, I want to check if the count is maybe greater than 10 at this point. If that is the case, I want to call log.println. And in there, I'm going to say could not connect to RabbitMQ, and then exiting. And then exit out of the application by returning my connection, which is nil, and also the error. But if we get past all of this, I also want to call backoff. And I want to increase this backoff by using time.duration. And inside of this, I'm going to call math library And on that math library, I want to use this power function to power the count of 2. And then multiply that whole thing using time.second. So that's my backoff. And then I'm going to sleep for this backoff. So time.sleep for backoff. But other than that, I also want to add a print line. So log.println. And I'm going to say backing of RabbitMQ like so. And then continue to the next iteration. But if all of this is gone well, I want to return the connection and nil for the error. By the way, I can also show you a smaller version like this. So we just have the connection and the error, and we have a set max retry, and then we have a for loop where we check if the current retry is under that max retry, and we try to connect to it. Much easier than before. So with that, let's now connect inside of our main function. So at the very top, I'm going to add a print line using log.println. And in here, I'm simply going to say starting listener listener service. Starting listener service. That's good. And now let's try to connect. So I'm going to call this connect to RabbitMQ, which gives me a connection and an error, right? So a connection and an error. So let's handle the error first. If error is not equals to nil, in that case, I want to call log.println and I want to print the error. Also, I want to call OS package. On that, I want to call the exit method with exit status code of 1. And after that, when the main function finally ends, I also want to call differ connection. So any connection must be closed. So connection.close, just like that. And then this is how we connect. Let's give it a try. I need to make sure that I'm pointed to my mother folder, go distributed microservice, and here I'm going to do make down and then do make up. So let's wait here just a bit. And here at this very end, we can see starting listener service connected to RabbitMQ. Now, in this lecture and in the next lecture, the code we are going to be writing is for setting up RabbitMQ infrastructure. And I'm going to separate them into their own package because some of this code would be reusable in other microservices. For example, the broker service, the logger service, and so on. So inside of my listener service, I'm going to create a new folder and I'll name it lib. And inside of that lib, I will have another folder. You can say event or maybe events. And the job of this function would be to declare a temporary private queue and not to share any existing queue. So declare random queue. You will see when we implement all of it. So this declare random queue will again take a channel, which is of type pointed to AMQP and their channel. Now this function is going to return two things, which is AMQP queue, because we're declaring a random queue, so AMQP.queue, and potentially an error. Now within this function, I just want to return the channel that we're getting, and on that, queueDeclare. Now inside of this queueDeclare, it's going to be pretty similar to this. First we have the name and we will set it to empty. So select your name. And just like before, if you hover on this queueDeclare, you get to see all the arguments that you have to pass for this queueDeclare method. Next thing would be, is it durable? So that is true. Do I want auto delete? No. Do I want it to be... I'll just grab this auto delete. Yes, that is the third one. Next is, should it be exclusive? Yes, true. After exclusive, we have wait, for which I'll set false. And next we also have arguments, which is nil. So just like that. This is how we set the infrastructure up for setting and getting events. So in the last lecture, we were setting up the infrastructure for RabbitMQ. So we declared the queue through which events are to be transmitted and the event, what sort of configuration should it have. Now let's move on to the business logic of this interaction. Within this event package, I'm going to create a new file and I'll name it consumer.go. And in here, like I said, we're going to establish the business logic. So we will have a few different things in here. First, let's declare the package, which is a package event. Other than that, we will also need this import. Next, we will have many different things in here. So let me just type them out for you. For example, we will have type consumer, and that would be a struct, right? And this would declare what a consumer is. So for example, consumer is the is the type used for receiving RabbitMQ, or I can say maybe AMQP events, right? Other than that, we will have a few other things. For example, we're going to have a function that would set up or initialize this consumer. So we can say function new consumer. And this would take a connection to the pointer of AMQP, and on that, the connection, the import is gone. Okay. This function would then return us a consumer and potentially an error. And these are the things we're going to work on later. Let's just set up the signatures. So new consumer returns a new consumer, right? What other things? We want a setup function. So say func setup. Now this func setup would be a method of the consumer. So I'm going to add consumer, which is pointed to consumer. And this function setup takes no argument, but potentially returns an error. And this is to set up. Basically, setup opens a channel and declare the exchange, all right? Everything will make sense when we start writing it out. But let's just declare all the signatures first. We will then have a payload for sending stuff. So a func payload, which is a type payload, which is a struct. And this payload is the type used for pushing an exchange. So pushing events to exchange, right? Pushing events to RabbitMQ. Or I can just say RabbitMQ like so. Other than that, we will then have a function, which is again a consumer method. And this is named as listen. and it is just going to take topics. So which topics to listen for. And we can have many topics, so I'm just going to make it slice of string. And this again might return an error potentially. So let me just say listen will listen for all new Q publications. What else? I think for the end, we can have a function that is to handle the payload, right? Just like the broker service, we will have the action, and depending on the action, we will switch on that and we will handle. So this is just going to take payload of type payload, something that we declared above, but we're going to work on everything later. And that is all for now. So let's start working. So we have to first declare this consumer and what this consumer is. Now, if you think about it, a consumer should have a connection, and this is the pointer to AMQP.connection. And it should have a queue name, and that can just be a string. So this is what a consumer is. A consumer has a connection to AMQP and then the queue name, right? Next, let's initialize a new consumer in this new consumer function. How do we do that? Well, let's create a consumer variable, and in here, let's declare that consumer struct. And this will need connection. So for this connection, we're going to pass the connection that we're getting as the argument. So we're just going to pass this con. And when we want to set up this connection on this consumer, we need to, we can put all the setup logic here, but I want to extract it into a separate function, which is this setup function. So in here, I'm going to say consumer.setup, right? This thing might return me an error. And so for the error, I should handle it. If error is not equals to nil, I'm just going to return an empty consumer and then nil for the error. But then if everything is good, I can return the proper consumer and nil for the error. And sorry, here I should just return the error, not the nil. So there we set up the consumer, what a consumer should look like, and then we initialize the consumer. Now in the initializing process, we need to set up the consumer, right? Which we said we want to extract out of this into a separate function. And this function might return us an error, and this is a method of the consumer struct. So in here, what do? We want to access the consumer. On that consumer, we get a connection on which we can call a channel. Like so. So this then allows us to get a channel and potentially an error. So let's handle the error first. If error is not equals to nil, what do? So if error is not equals to nil, I just want to return the error itself. But if no error was found, I want to return a declared channel, right? So that is something we declared here, that we have a declared channel, a declared exchange. So that is what we want to declare. So declare exchange, and to this, we then pass the channel. And if you remember, it takes a channel. So that marks the end of the setup. Let's now move on to the actual transmission of the things that would be sent and received through the channel. So let's work on the payload, because payload is what we want to send and receive. Now, what should a payload have? It should have a name, which is of type string, and I'll add some JSON tag to it, like so. And the second field would be data, which again is string for now, and JSON tag name would be data. So this is what a payload looks like. Next, we want to make sure that we can listen from this listener service, and we want to listen to the RabbitMQ database. So this is what we're going to set up now. So in the listen method, what do we want to do? Well, the first thing is we want to set a channel again. So we want to access the consumer. On that, we get the connection. And on that, we have a channel method. This would again give us a channel and an error. So we should handle the error first. I'm going to say if error is not equals to nil, I want to just return the error. So return error. But if no error was found, I want to differ close it. So any channel, we have to close it. Differ close the channel. So then we now want to get a queue. So we want to make a transport layer from this listener service to the RabbitMQ server. So we want to make a transport layer by calling declare random queue. Because if you remember, I said this declare random queue generates a temporary unique queue for us. So in here, I then want to pass this channel that I created above, and this then gives me the queue and potentially an error. So let's handle the error. If error is not equals to nil, I just want to return the error. But if we get past that, I now want to range over all the topics that we're getting and work on that. So I should create a for loop, and I don't care about the index, but I care about each of the string there, so each of the topic. And when I range over the topics, right? So in here, I want to access the channel, and on the channel, I have a method known as queueBind, right? I want to bind to the queue, and I want to bind the queue.name. That's the first thing. I also want to pass the topic itself, and I want to get the name of the topic. So I can just call get exchange name, and that's a function we have right here. Next, I also want to set the other parameters, which are false and nil for the argument, right? So this thing then gives us what? It gives us an error potentially, which we are to be handling. So next I can then say if error is not equals to nil, I want to call log.println, and I want to print the error, and then I want to return the error, like so. So with that, that is our for loop, and the job of that for loop is such that it is just going to range over the topics and create a binding to the queue, right? Next, with the queue now ready, we should prepare the message that is to be sent. So I'm again going to call the channel, and on the channel we have the consume. So I want to consume from the channel, and I want to consume where the name of the queue is queue.name. I don't care about the name of the event. I do care about the next arguments, which are true, false. If you see, exclusive, no local, no wait, so true, false, false. For the next one, false too. And for the last one, nil for the args. So when I consume this channel, I get the message, or messages actually, and an error. Now, first thing is first, I'm going to handle the error. If error is not equals to nil, I just want to return the error from here. But then again, if everything is good, what do I want? I want to range over all the messages that I have, and I want to launch a function to handle those messages, so handle the payload, right? So what I'm going to do is I'm going to create a for loop, and this would give me each of the item. And I'll get that when I range over the messages. So in here, first I'm going to create a var payload of the payload type that I declared above, and then I'm going to fill this payload up. So I don't care about the error, and when I call JSON dot marshal, and I want to marshal to the d.body, and I want to marshal the pointer to this payload. The next stuff is to handle the payload. So I'm just going to call this handle payload. And to this handle payload, then I'm going to pass the payload like so. Now I have an error here. Actually, it's wrong. It should have been unmarshal, right? So now the interesting part begins. I want to listen to these messages forever, all right? I don't want to just get the first few messages and then call it a day. I don't want that. I want to listen to these messages forever. So I need a way to make it work over and over and over again. So the best idea is to create a function out of it. So I'm going to extract it and create a Go func, which creates a Go routine. And in this body, then I'm going to paste that. Now, if you know anything about Go routine, if we launch a Go routine, this much of the code will be extracted from this main thread and it's going to run in its own thread. And then the listener service function, the listener service application is going to exit immediately. We don't want that. We want to keep it running forever. So we're going to create a channel and we're going to block it right here. So this function never ends and it listens forever. So right above that Go function, I'm going to create a channel and I'm going to name it forever. So this is a channel and we use the make keyword to create a channel. And the type of this channel is going to be Boolean, right? Now, after that Go routine function, this is where I want to end it. So this is where I'm going to hold so that it stays stuck and it keeps running forever. And by the way, in here, I'm also going to add a log.println and maybe I should add a log.printf. So in here, what I want to say is I want to add a point and I'm going to say waiting for message. And I want to also add some more details. Exchange, CHAN, exchange and name, right? Or maybe exchange and queue sounds better. And then in here, I'm also going to pass the values. So percent %s, comma, percent %s. And then I just want to pass the values for both of them. So the first one was this get exchange name. And the last one would be the queue and its name. So queue.name. Now, after the channel, I should then return nil because I have no error to return. And that is the end of this function. Now, please remember in this listen function, we declared this handle payload, right, in a separate Go routine. So now let's work on that handle payload function. So the job of this handle payload, what is it? Handle payload takes an action, all right? It's going to take an action and it's based on the name of an event in the Go routine, okay? Or actually in the queue, yeah, sorry. So now this handle payload, like I said, it's going to have a switch statement. So I'm going to switch on that payload and there the name dot name, right? And let's say for the first case, we have a log. So maybe a request came to log something. Or maybe a request came for an event. So if these are the case, what do we want to do? If these are the case, I'm going to create a new function which would be named as a log event. And this log event is very similar to the function we have in broker service. So there in the handlers, we have this log. It's going to be extremely similar to that. All right. So this log event is then just going to take the payload and it will potentially return us an error. So I want to already handle the error here. So if error is not equals to nil, I want to log.println the error. All right. Also, other than that, I want to add a default clause. So default. So if anything comes in that we do not recognize, I again want to call this error log event. So now all that's missing is to create this log event. Let's create that function. So I'm just going to create this function right in here, func log event. And it is just going to take the event or maybe an entry of a payload. And it might return us an error like you know from before. And what's the thing that we want to do? Well, like I said, it's going to be extremely similar to the broker service. So I'm going to call the JSON package, and on that I want to marshal indent. And I want to marshal the entry that I'm getting. And I don't care about the prefix, but I want to indent it with a single tab, like so. This would then give me the JSON data and an error, which I don't care about. So next I want to make a new request, right? So I'm going to call http dot new request, and I want to make a post request, and I want to make a request to the logger service. So http colon double slash logger is the name. Let me check the Docker compose. Right, logger is the name. So logger, and the endpoint was slash log, and the port was colon 8080. Sorry, this should go right here. And then I want to bind the JSON data. So I'm going to call the bytes package dot new buffer. And in there, I'm just going to pass this JSON data. This would then form a request, request, and potentially an error. So let's handle the error first. And I'm going to do if error is not equals to nil. I just want to return the error from here. Next, I want to make, I also want to set the request header. So request.header, and there I want to call set. And I want to set the content type like we did before. And I want to set it to application/JSON, right? The next thing is to create a client. So I'll create this client variable, and we've been doing this over and over again already. And it takes a pointer to http.client struct. Next on this client, I want to call do. So client.do, and it should do the request. So this then yields us a response, potentially also an error. So let's handle the error. If error is not equals to nil, I just want to return this error. But then again, if we get past this error, I want to differ close the response. So differ, and on that response.body, I get this close. So after all of that, I then want to check if response.status code is not equals to HTTP, and our success code was status accepted. So if that is not the case, I also want to return an error. But if we get past all of those, I can just return nil because there is no data to be returned. And then that is the whole business logic for this consumer at this point. So now let's head back to the main.go of our listener service. And we know in the main function, we declared some comments for us before, some helper comments. Now the main function has two parts. The first part is this, which connects to the RabbitMQ, and the second part is that listens for RabbitMQ, right? So let's start with the second part now. It's going to be super easy. I'm just going to add a simple comment in here, and I'm going to say log.println, and I'm going to say listening listening for RabbitMQ. I can say listening and consuming for RabbitMQ messages. Sounds fitting. Like so. I'm just going to remove this. So next, let's create or what to say? Let me add something. So this is the first part, and then here starts the second part. Just decorating things a bit for future reference. So anyways, let's now create a consumer, and we have a function to do that, right? So we can access the event, listener lib event. Yes, that is the event we want. And on that, we have this new consumer. So this new consumer takes a connection, and we can just pass the connection that we're getting. And this then would give us a consumer and an error. So if error is not equals to nil, I can just call panic, because there is no point in moving forward. So panic, and on that I pass the error. So that's that. And then we should watch for the queue and consume events. So we want to again access the consumer. On that we also have the listen method. And this then takes a slice of string. So string, and we can have as many of them as we want in here. I'll add 3, but chances are I'm just going to use 1. So for example, log.info. You can have log.warning. We can have log.error, and so on and so forth. This again might give us an error, and we should handle it. So I'm just going to say in here, if error is not equals to nil, log.print ln the error. And can we return out of it? I think we can. And then that is it. So with the preparation of connecting the broker to the listener service and also the RabbitMQ now done, we should now add the infrastructure and the business logic from that RabbitMQ into the broker service as well. So in the RabbitMQ listener service, we have the lib. I'm just going to grab this lib in its entirety and paste it inside of this broker service. I want to get this lib and paste it in here. So there we have it. The next stuff is to, of course, we have everything from that event as usual, but also I now need to add an emitter, because if you remember, the listener service listens to the RabbitMQ, but this broker service would push things into the RabbitMQ, all right? So to do that, inside of this event, I'm also going to add emitter.go. And this is package event, and we need to add some functions and methods into it. The first thing is that I'm going to add this import. Don't need any of this. Now let's declare what an emitter is. So type emitter, which is a struct. And this is just going to have a connection. And the connection is a pointer to AMQP and connection there. Yep, so connection, right. Next, we will need a few functions. So the first function is going to be a method of that emitter. So E pointed to emitter. And we're going to name it setup. So it's going to set the whole thing up. It's just going to return a potential error and nothing else. So in here, we want to access the emitter, and on that emitter, we have a connection, and on that connection, we have a channel. So this gives us a channel through which things are to be emitted, and also an error. So if error is not equals to nil, I want to return the error only. But if we get past that, I want to differ close the connection. So differ the channel, and on that I want to just call close. And next I just want to return it using the declare exchange, and which would then take the channel, right? Because we need this declare exchange if we want to reach out to the RabbitMQ server, because if you remember, this declare exchange gives us a temporary unique queue. So that's the first function. The next function is to push things to the queue, right? So we're going to create a new function, which would again be a method of that emitter struct. And this is going to be known as push. Now this push is just going to take an event of type string and a severity level. So severity, severity, which is also a string. And potentially an error. And it's going to return a potential error. Now in here again, we need to access the emitter, and on that emitter, we want to access the connection and there the channel. So this gives us a channel and a potential error. And I want to handle it. If error is not equals to nil, return the error. And then of course I need to differ close it. So differ the channel, and on that channel I have a close. After that, I want to print a log statement, so log.println, and in here I'll say pushing to channel, right? So pushing to RabbitMQ. And we can do that using channel.push or publish. And this is going to take a few arguments. So for example, the name of the topic, which is logs_topic, right? And let me see the event. Basically, I can just say in here, get exchange name. So that's the first thing. I also have to pass the severity level. And actually, I'm just going to keep it as logs.topic explicitly. So then we have this severity level. I want to set false, false again. And then for the message, I want to use the AMQP, and on that I have this publishing struct, which would take the content type, and the content type here is text plain, because we're just passing simple text, like so. And we will also have a body for which we need to use byte slice. So byte like that. And then using parentheses, I want to add this event into that. And then I have to see this publish. This gives me an error, so I should handle that. So if error is not equals to nil, I just want to return the error. But if everything is well, return nil for the error. So that is then the push. Right here. Well, this push is not all. We also need a function that would emit a new event, right? So it's a new function, and it's known as new event emitter. So whenever a new event is formed, we want to emit it using this function. And this would take a connection to pointer AMQP dot connection. And this is just going to return us an emitter and a potential error. So the emitter, we have to create a variable first, which would hold the emitter struct. And this emitter struct takes a connection, and this connection is the connection that we're getting here. After that, we want to call this emitter, and on that we have the setup method, which, if you know, of course, is going to yield us an error. So if error is not equals to nil, what do we do? Well, I just want to return an empty emitter struct and the error itself. But then if everything is good, I want to return the proper emitter and nil for the error. So that is all. That is all for this emitter. And in the next lecture, we're going to set up the router and the handler so we can actually make a request from this broker to the listener service. With our listener microservice now ready, we can move to the other microservices, for example, the broker service, such that it can communicate with the listener service, and through communicating the listener service, it puts things in the RabbitMQ DB. So let's go to broker service, and there's CMD main. Now we need to do a few things in here. The first thing is we need to install the RabbitMQ package. So let me go to cd broker, and I'm going to install the RabbitMQ package. So go get github.com/RabbitMQ/AMQP091-go. And you need it for any of the microservice that would connect to the RabbitMQ, right? So that's that. Now in here, for the application struct, I want to add this Rabbit connection. So I should also import that thing, which is AMQP, and we get it when we go to github.com and here, like so. So this Rabbit con is going to be pointer to AMQP and there a connection. Right. The next step is to connect to the RabbitMQ. So let me go back to the listener service, the main.go, and I'm just going to copy this connect to RabbitMQ and paste it in here of the main.go of the broker service. Now to connect it, I should also get this much, and that is the first thing I'm going to do in here. So with that, we now have a connection to RabbitMQ, which we should use in this application struct. So the RabbitCon takes this con. And that would be all for now, except we need to handle this error because this is not the first error anymore. This is. So for now, that is good. In the next lecture, we are going to make the handler such that it can handle request for RabbitMQ incoming requests. Now, let's seal the deal. We go to the handler of our broker service. And if you remember, there we already have log payload. We have a handle submission, which handles the logging, right? But now we want to also log through the RabbitMQ. So let me just add the function here first, and we are going to add two functions. The first function would be to actually handle the log. So for example, that would be, of course, a method of this app, which is pointed to application. And I'm going to give it a name of log event, or maybe log via RabbitMQ, all right? Just a descriptive name. And this is going to take a W, which is http.response writer, and it's going to take a payload, which is log payload. Now this potentially might return us an error or not. It shouldn't return anything. So this is the main function that we're going to carry out. And we're going to do it such that we should also create a utility function to so that this function can actually use the RabbitMQ emitter, right? So for that, I'm going to create a separate function in here. And this too is going to be a method of that application struct. And the name here is just going to be push to AMQP, all right? It's a very descriptive name, and that is good. Now this is just going to take a name and a message, both of which are of string. and it potentially might just return us an error. So in here, we need to set up the emitter so I can access app and sorry, not app. I can access the event from broker lib event. And on that, I can create a new event emitter. Now this emitter is going to take a connection, which I can access via app.rabbit connection. So this then would yield me an emitter and a potential error. So if error is not equals to nil, I just want to return this error. But if we get past that, I want to create a payload, and this payload is going to be of type log payload, right? This takes a name, like we know, and the name is the name that we're getting as the function argument or parameter, and the data taken by the log payload is the message we get from the function parameter. The next step is to marshalize it using JSON and send it. So I don't care about I just care about the data. I don't care about the error. When I would call JSON package and on that call Marshall, well, we can call it Marshall indent, no problem. And I want to pass a pointer to that payload. I don't care about the prefix. However, I want to indent it by a single tab. Next, I want to call the emitter. And on that emitter, I want to call push. Now this push should convert everything to a string. So I'm going to bring this string function and I'm going to push the item that I get here, this JSON. And I want to push to a single topic, which would be log.info. Now, please don't make any mistake. If we go to listener service, there the main.go, we have this log.info, and this is the topic to which we want to push. So that is good. This emitter.push might yield us an error, so we should handle that. If error is not equals to nil, return the error, or else return nil. And this is then the utility function for actually logging things to the AMQP or RabbitMQ. So let's get back to that. So in the main function in here, which is the log via RabbitMQ, in this function, I want to call the app. So our application struct. And on that application struct, we have a function which is known as push to queue or push to AMQP, the one that we just created. And this takes the name, which I can get from the P and there the name. And it also takes some data, which I can get from p.data. This might return me an error, so I should prepare to handle it. And I'm going to do if error is not equals to nil. I want to call app.errorJSON because please remember this broker is now communicating back to the user with either success or failure. So this should take the W and the error and then of course return out of it. But then again, if everything went well, I can now create a success response. So I'm going to do var response, which is a JSON response. And on this response, I'm going to set the error to false. And also this response gets a message. And I'm going to set it to logged via RabbitMQ. And with that, then I can send the response back. So app.write.json. So it takes the W, it takes a status, and I'm going to add http.status accepted. And then also actually, I should name it payload to be idiomatic. And then that is it. All we now have to do is go back to the handle submission and make sure that that is handled. So I'm going to add a new log case. And here I'm going to say log-mq. Now this is going to then take this log via RabbitMQ function. That's the end. So now let's just try everything out. I'm just going to cd dot dot out of it. And first I'm going to do make down. And after that, I'm going to do make up. And let's wait here just a bit. While we wait, let me open up Postman. And in that Postman, I need to see this handle submission because it takes log-mq. So that's the action. So in here, I have this test broker log, and I'm just going to duplicate it. And I'm going to rename it to test broker log dash mq. All right. So if I go to the body in here, this is no more log, but this is a log dash mq. So with that, if I send this, it says logged via RabbitMQ. And let me also open up the browser and refresh it. Let's see if we have anything. We have two connections. That's good. One from the listener service and one from the broker service. We have two channel. Do we have an exchange? We do have an exchange. We have a logs topic. And let me see the publish message. Well, I don't see anything in here. But the good thing is I should be able to open up my MongoDB Compass. So MongoDB Compass. And connect through this. If I go to logs, I get to see a third item. And today is the, yes, this is the 18/4/2026, 26/4/18, and this is the only thing I logged today. So this worked. Congratulations. With our microservices now complete and connected, we can now move on to more advanced topic. For example, in this section, moving on, we're going to learn how to connect the microservices together with something better than HTTP. Up until now, we have been using HTTP for connecting everything. So the front end connects to the broker using HTTP, and also all the microservices therein is connected using HTTP. Now, please remember, HTTP is perfectly fine for connecting the browser to the broker, and that is how it should remain. But connecting the microservices between each other has better options. For example, RPC and gRPC. And in this section of the course, we're going to learn about this RPC before we jump into gRPC. Now, RPC stands for Remote Procedure Call and is much faster for marshalling and unmarshalling JSON. So how do we do it? Since the implementation is going to be same for all the microservices, I'm just going to show for the broker and the logger. And in the logger is where I need to create a RPC server so it can start listen for incoming requests from the broker. So let's head over to the logger service there in the CMD API. And in here, I'm going to create a file rpc.go. And of course, this is package main. Now, to make an RPC work, three things are super important. Actually, four things. The first thing is creating an RPC type. Then the payload that would be transmitted over the RPC, so another type for that. Third is the function that would trigger such an exchange. And fourth is creating the RPC server and making it start listening. All right. So let's get started. The first thing is that we need a RPC type, and I'm going to name it RPC server. And this is a struct, and this is empty. Next, we need another type, which is RPC payload. And that is another struct. And for our logging, we know we just have name, which is a string, and we have a data, which is another string. So those are the two things. Now the third thing is the function that I talked about. So a function, and this should be a pointer receiver for that RPC server. So R pointed to RPC server. And I'm going to name it log info. Now, what are the things that this function should take? Well, first of all, it needs to get the payload. That's normal. So a payload which is of type RPC payload. And the second argument is a must, which is a pointer to string, and this is the data that would be sent back. And I'm just going to name it response. Now, this function has a potential error return type, so now let's work on it. Well, the first thing is that I want to get the data that I am going to get, right? And the data, this RPC payload, should be converted to the log entry, if you remember. So I'm just going to make a variable here, and I'm going to name it entry. And this is of type data from the data package, and they're the log entry. And it has two fields, name, which should come from this payload.name, and it has a data, which should come from that payload.data. So there we have our entry. Next, we need to insert it to our MongoDB, so we can then access the application. Not really, we can access the data, and on the data, we have this data.models, and on that model we have log entry, and on that we can do well, it seems we can't just enter the log entry insert directly, so let's create our collection first. And to enter the collection, we have a global client variable. Let me go to the main.go. We have a DB variable. So we have the DB. What's wrong? Let's do something. Let's create a global DB Mongo variable here as well. Var DB, which is a Mongo client. And if we do so in the connect to database, we get our client right in here. And after we check the error, we can call that DB and make it equals to the client that we're getting. So if we do that, we now have a global Mongo client. So right in here, I can then do DB, and on this DB, then I can access the database. I can. And the database I want to enter is this logs database, and there I'll have a collection. And the name of the collection, let's go to the data, and there the log entry. And the name of the collection is also logs. So that is what I want to enter. So there I now have my collection, and now I can enter everything. So I don't care about the result. Just let's handle the error. When we want to enter this collection, and on this collection, I want to insert one. And the first thing is we need a context. So we can just use the context package and there the context.todo. And the data we want to enter is this entry. I think it also needs a created at, for which I'm just going to use time.now. So that's that. Let's just handle the error. If error is not equals to nil, I want to return the error, and I also want to log.println the error. But other than that, I just want to return nil. So those were the first three things: the RPC type, the payload type, and a function to interact with over the RPC trigger, right? The next thing is that we implement everything into main.go of this logger service. So let's head there. In this main.go, I need to create another function that would listen for this RPC. So I'm going to create another function, and this is also going to be a pointer receiver of app, which is pointed to application. And I'm going to name it RPC listen. Now this RPC listen might return an error. And in the function, what do we do? Well, first of all, I'm going to add a log.println, and I'm going to say listening RPC server on port, and then I need to add a port. So do we have a port? We don't. So let me create one more constant, and that would be RPC port, and I'm going to make it 5001. All right. And so in here, then I want to add this RPC port just like that. So that's the first thing. The second thing is that we now need to start listening. So I'm going to use this net package, and on that net package, I have this listen. Now the protocol to be used would be TCP, and I need to use fmt.sprintf. And then I need to pass a address, right? So I'm going to use 0.0.0.0 colon at my port. So that should be %s, and then the RPC port is to be passed. So this then gives me a listener or an error. So let's handle the error first. Going to do if error is not equals to nil. I'm just going to return the error out of here. And also when the function finally closes, I want to differ close the listener. So listen.close, like so. Next, I want to keep listening forever. So I'm going to use a for loop. And within this for loop, I'm going to call that listen. And on that, I'm going to accept this listener. So this then gives me the RPC connection finally, and a potential error. So if error is not equals to nil, I want to continue. But if everything is good, I can then call this RPC from net RPC. And there I have this server connection, to which I'll then pass the RPC connection like so. And this statement here should be launched in a separate Go routine. So I'll add this Go keyword right in front of it. And then this is my function to trigger the server for listening. So up here in the main function, where we listen here at HTTP server, right between here, I'm going to make that work. So the first thing is that I need to register this RPC server that we created. All right. So for that, I'm going to call RPC package from net RPC, and on that I have a register function, which takes a new function, and instead of that, I want to pass this that RPC server. Now this might give me an error, and so after that, I also want to call the app.rpc listen, and that should be in a separate Go routine, like so. and that is fine. So that's how we add RPC into our program. So with the RPC server now up and running inside the listener service, we now want to create a function that can trigger RPC call from the broker to the logger service, right? Such that when we make a request from the front end to the broker, we can make a special RPC request, right? Like for the RPC request. So in the broker service, we should go there to the handler. And if you remember before in the handle submission, we now have two different forms of logging. So one log was for normal log using HTTP, and then we have a log for doing HTTP, and this time the log goes via the RabbitMQ. Now, this time, let's make another log, which doesn't matter. It goes via RabbitMQ or not, it doesn't matter. But what we want to test is that is the RPC working instead of the HTTP. Because if you remember, in the logger service now, we do have a RPC server. And this video, you will see that we won't make any HTTP request. For example, the way we were doing up in here, we won't do any HTTP request. We will do RPC request. So I'm going to create a function and I'm going to name it. What was the name for log via? So let me just grab this name and I'll remove everything from inside and I'm going to name it log via RPC. That seems like a fitting name. Now I need to have a data type here. So type, and that should be RPC payload. Because I need to mention what is the data that should be transmitted, right? And it needs a name, which is a string, and it also needs a data, which is another string, of course. So now, inside the function, well, the first thing is we need to access the RPC package from netRPC, and there we need to create the connection using this dial. And the protocol to be used is that TCP, and the address to connect to would be the name of our service, so logger service, and there the port was 5001. So let me just make a quick check. Yes, 5001. So that is good. This then gives me a client and a potential error. So let's handle the error first. If error is not equals to nil, what do we do? Well, we want to send a error response. So app.error JSON, which takes a W and the error. And then we simply return out of it. But if we get past this error, I want to now prepare the payload. So I'm going to create an RPC payload variable, and this is of type RPC payload type. And the data to go inside would be the name, which comes from the P, so the log payload right here, and there the name. Also, we have data, and that comes from p.data. Next, we need to also prepare a different variable, which would be a string, and the job of that variable is to get the data coming from the RPC request, right? So a var, and I'll name it result, and this is string. Now, if you remember, we declared a pointer string before, right? In the last video. That is what it is. And next, I want to use this client.call, and we need to be very specific now. We want to make a call to the RPC type in the logger service. So to this thing here, so this RPC server, just grab the name, and on that RPC server, the name of the function was loginfo. So we need to be very specific. This is the fun part of RPC and gRPC, that you directly call the function as if they are in the same computer, right? Next, the data to be added is this RPC payload, and the data to be filled up is a pointer to this result. All right? So this might give us an error. And if error is not equals to nil, we just do this. But then again, if everything is fine, we can now prepare a JSON response for the client, right? So I'm going to make another payload. And this payload is a JSON response. So there the error is false. Next, we have the message. And in here, I'll simply just pass the result because that is a string already. And so with that, we can send a success response to the client back using app.writeJSON. So I need to pass the W here and a status code using HTTP, and I'm going to use status accepted. And I'll attach this payload. So that is it. And one more thing, we now have to make this function work. So let's go up in the handle submission and let's add a new case. So I'm going to name it log RPC, and the name of the function is this log via RPC. Let's now test the RPC connection. But first, there is some error and some addition that we have to fix. For example, in the rpc.go, the RPC server should take a Mongo client. Because remember, we registered this in main.go. So instead of having a global DB variable here, just remove the global DB variable that we wrote. Also in the connect DB, there we set the DB to client, also remove that. And make sure that in the RPC, we now add this DB dependency, right? Next, in the log info, we can then access this method to RPC server, and there we can access the DB. So two things here. In the main.go, like I said, remove the global DB variable, first thing. Second thing is to remove the DB equals to client from here, second thing. And the third thing would be in the main function, we should initialize the pointer to RPC server and there set the DB to the DB that we're getting. And next, you can just do rpc.register and directly register the RPC server. No need for a new function. So with this few small changes, you can now open up your terminal. First do make down and then make up. And wait for a while after everything is running. You can go back to your Postman and duplicate the test broker LogMQ to now say log RPC, and then the action should be log RPC. And then add your favorite name and data, and then send the request. And voila, we have a successful response. Welcome to the new course section on gRPC. So in the last course section, we learned about RPC, remote procedure call, and the drawback of RPC was that the client and the server, so both the microservices that are connected via RPC has to be in the same language. At least in terms of Go, both has to be in Go. Well, this time we're going to learn about gRPC, and this is a more advanced way of connecting to microservices. And the main benefit of gRPC is that two of your microservices can be written in two different languages. But since we are using Go for everything, it's fine. But nonetheless, we are going to take a look at this technology gRPC, because our entire course is about Go backend mastering, right? And we want to make sure that we cover all the latest and greatest technologies. So enough talking. Now, on gRPC, I do have an in-depth course on YouTube, so you can search my channel at Boydutik, and you will see this Go gRPC crash course. But nonetheless, let's install gRPC. So on Google, search for gRPC and then head to this grpc.io. And because we are going to be using Go is what I'm going to select under Get Started. Now in here, you will see some prerequisites. The first thing is you need to have Go installed, which we already have. The next thing is to have a protocol buffer compiler of version 3. So let's install that. You can just open this up, or you can search for protobuf. See? So yes, even if you search for protobuf, it takes you to the same exact place. So then in here, we come to this protoc installation, and you will see install precompiled binaries, any operating system. So I'll go to this GitHub pages. And because I am on a Windows machine, well, let's get this latest version. I'm going to show all asset and download this Protoc 34.1 Win64 zip. So if you click this, it will start downloading. However, if you are on any other operating system, ask an AI to help you regarding this. So with that, because I already have downloaded it, let's just install it. So let me unextract it. So like extract it. And I'm just going to cut this out. I'll cut the extracted folder and then I'll go to my users, then me, and then in here I should have a folder known as develop. Right, I do have it. And this protoc is where you want to paste it in. So you can just paste it in like this. The next thing is I'm going to rename this protoc 34.1 Win64 into protoc. So you can just rename it. All right. Next, go inside the protoc and inside bin, and here you will see the protoc compiler. So just grab the entire thing and then search for env. Next, go to environment variable and then go to path, edit, and new, add this in. But I already have it from before, so I'll not do that. Also do the same for the system variables, and here search for path, edit, new, and then add that in. But I already have it from before. So next, let's see if the installation works. So I'm going to open CMD and I'm going to search for PROTOC. I'm going to write protoc. And because I get an output and no error, so protoc was successfully recognized by my Windows machine. The next stuff is to go back to that gRPC. So we now have Go, we also now have protocol buffer compiler. The next thing is to install the Go plugin for this gRPC and protoc. So just grab this entire command and go back to your CMD and just paste it in. So it might just take a little while. There it is. So let me just grab this batch and space version, maybe dash dash version. All right, so I have the version 1.36.11, so all good. gRPC and protoc compiler was installed successfully. Now the next step is to go to your VS Code and there the extensions tab and search for protobuf and then install the extension protobuf by pbkit. At this point, we do have all our necessary tools and extensions to work with gRPC. So let's get forward. I'm going to go into the logger service and I'm going to create a new package and I'm going to name it logs. Now inside of logs, I'll create a new file and I'll name it logs.proto. This is important. The extension has to be .proto. And in this proto file, we are going to declare what sort of syntax we want, what are the data types that should be transmitted over gRPC, and what are the function calls that should be called later, all right? Now I'm going to write some code first, and then I'm going to explain everything. So syntax is equals to, and in double quotes, it goes proto3, and then end with a semicolon. And this is a must. Every proto file must start with a syntax declaration. Which proto syntax do we want to use? And this is proto3 syntax. And every line must end with a semicolon. The next thing is the package that is to be produced inside would be package logs, like so. And of course, a semicolon. Next, the option. And the option should be go underscore package. And this is equals to, in double quotes, slash logs, pointing to this logs. And of course, end with a semicolon. So these three things are a must at the beginning. Next, I want to declare data types. And to declare data types, we say message followed by the name, and I'm going to give it log. So what does a log look like? It is a string, and the first value is the name. And this is at position 1. One is not the value, but it is the position. The next thing is another string, which was data, and this is at position 2. So that is what a log should look like. Next, let's declare two more message, one for the log request and one for the log response. So message log request. This should have a log thing. So log, and I'll name it LogEntry. And this gets a new position of 1 inside this message. After that, I'll move to the third message, which is log response. And this will simply transmit a string, and we will name it result. And this again gets a position of 1 inside this new message. So there we have 3 data types known as messages. The next thing is to declare service, and inside of this service, we declare all the function names, our function signatures. So I'll name it log service. And this will be a RPC call, and the name of the function would be write log, and that would take a log, request, log request. And it is going to return something, and that would be log response, like so, and then end with a semicolon. And the log request and log response goes in parameters. So then this is what the proto file is. In the next lecture, we are going to generate this using the Protoc compiler. All right, now let's use the Protoc compiler to generate source code from this proto file. I'm going to open up a new terminal, and I need to first go to this logger service. So I'm going to cd into logger service. Now inside this logger service, I want to call the Protoc compiler, PROTOC Protoc. And on this proto compiler, I need to set some flags, and I also need to say which proto file is to be parsed. So the first flag, space dash capital I, is equals to logs. And this means where my .proto files are located. For example, here in this logs folder. Space, for the next flag, I'm going to do dash dash go underscore out is equals to right here. And this means generate the go structs from these messages to where? So right here in this current directory. Space, the next flag. So the third flag would be dash dash go dash gRPC underscore out is equals to right here as well. And this means where the gRPC client and server code is to be generated. Next, for the ending, we have to point to this log.proto. So right here, we're going to say parse this logs. So this logs package, and there the logs.proto file. And click enter. And now you see two files were generated. And these two files are never to be edited by hand manually. And by the way, this command right here, I'm going to just copy it out. And inside in here, I'm going to make command.txt and paste it right here for your future use. At this point, we have installed necessary equipments for gRPC. We have a good look at the proto file, and we have also generated things from it. Now, this is time that we implement a gRPC server and make sure we complete this write log function, right? Because this is something we have declared, we have never written it fully. And also we need to create a server for this logs. So those are the two things we will do. But first, if I go into this logs gRPC pb.go, you see I get an error here, could not import google.golang.org/grpc. So this is one thing. And the other thing is inside logs.pb.go, it says could not import google.golang.org/protopath. So let's import both of them first. I need to open a terminal and I need to go inside cd logger service. And in here, I'm going to do go get google.golang.org/grpc. So that is getting in. And the next thing is to go inside logs_grpc.pb.go. And in here, I need to install go get google.golang.org/proto-buff. And all the error has now gone. So with that, now let's start working. And the place that I'm going to work in would be inside a new file known as grpc.go. So I'm just going to go inside my logger service. There's a CMD, and inside the API, I'm going to create a new file, and I'm going to name it grpc.go. It will be something very similar to this RPC file. So I need to have a server declaration and the function. So let's get started. This is package main inside grpc.go file. And the first thing is that I want a server, a log server. So type log server, and this is a struct. So this will have some items in here. And the next thing is a function. So a function which gets a receiver of L, which is a pointer receiver of that log server. And the name of this function is that write log, because now we are implementing this write log, this RPC write log that we declared in the service. All right. So write log. Now this function has to take a context as the first argument. So I'll name it ctx, and it comes from the context package, and they're the context type. That's the first argument, or the first parameter. The second one is a request. So the request that is coming in, and that is a pointer to the logs package, and they're the log request type. All right. Next, this function should return something as well. Of course, it has to return the response, so pointer to logs.log response and a potential error. So these are the two things we need. So let's work on the log server first. What do we have for this log server? Well, for the log server, when we generated the file, something was generated for us. If we go into logs, and they're the unimplemented log service server. This is what we need as the first thing. And it was generated for us because this is what we call to start generating or implementing the server. And this also ensures backwards compatibility. Next, we need our models. So I'll name it models. And that can be found inside data package, and they're the models. So these are the two things I need for this log server. And this one would be used to access all the log related items, and using these models, we can then access MongoDB to store data. So that is what the log server needs. And now we also have a function method, which is a method of this log server. which takes a context and the pointer request to log request and a returns pointer log response and then a potential error. So now inside this function, well, we want to get the input that is coming in. So the input, and that can be found using this request that we have. And on that request, we can access this get log entry. And this was automatically generated for us because we had the log entry. So under the hood, it knows that we want all the items of log entry as well. Next, let's create a log entry. So a variable entry entry, and this would be data package, and they're the log entry type. And this will take the name, which can be gotten from the input.name, and it also takes a data which can be gotten from the input.data. The next step is to save it. So I can access the logger server, and on that, then I can access the models, and the models has access to log entry, and the log entry has access to insert, which can then take this log entry that we created up here. Now this thing can of course yield an error, so we should handle it. And we're going to say if error is not equals to nil, so what do? Of course, we want to send some error response. So a response, and we can now access pointer to logs. They're the log response, and we can fill this up. So it only takes a result, and for the result, I'll simply say failed to insert using gRPC, all right? And then return out of it. And this here should take a semicolon. And I want to return this error result and the error itself. But if we get past this error, it means we have a proper success. So next we create another response, and we're going to call pointer to logs.log response, and we are going to fill the result, and I'm going to say logged using gRPC, and then I can return this response and nil for an error. So that is what it is. The next and final step inside of this logger service would be to start listening for gRPC connection. And for that, we need to create a new function. And I'll name that gRPC listen, which I will then implement inside this main.go. So let's get started. So a new function, and this would get this app, which is a pointer of application, and I'll name it gRPC lis listen. Now this takes no parameter and returns nothing. Now inside of this, what do? Well, very similar to RPC server, we need to call the net package. And on that net package, we have this listen. And it should listen through TCP connection, TCP protocol. And it needs to listen at a port. So fmt.sprint, sprint and here I want to pass colon %s, and the value of this %s would be gRPC port. Now this gRPC port is something we don't have, but I'll declare that. So now this gives me a listener and also an error. So if error is not equals to nil, what do I do? Well, if error is not equals to null, I want to do log.fatalf. And in here, I'm going to say failed to listen for gRPC. And also I want to add the error using %v and pass the error right back here. Hello? Hello? কি খবর? খবর ভালো, কও কও। গেম খেলবা? মাশাল্লাহ। ওকে ওকে। জামাই কোন জায়গার? মাশাল্লাহ, ভালো তো। এই তোমার আপন বোন? ও, তোমার কি একটা ছোট বোন একটা বড় বোন? ও, মাশাল্লাহ মাশাল্লাহ, ভালো ভালো। কার্ড তো দূরের মান ছেড়ে দেয়, আমগো কার্ড লাগতো না। ওকে ওকে, সুসংবাদ। ওকে লাভ। হ্যাঁ, আল্লাহ হাফেজ। So that is that. And if we get past this error, I now want to create the gRPC. So I want to call this gRPC package, and on that, call the new server. All right. And this gives me the gRPC server. So next, I want to call the logs again. So the logs package. And on this logs package, I now get the register log service server. So I need to call this. And to this, I'll pass the gRPC server. And I also need to pass this log server that we created up there. So it will take a pointer to the log server. And this log server, if you remember, takes the model and the unimplemented log service server, but that is something you don't need to pass. You just need to pass these models. So for these models, we want to access the app, and on this app, we have our models. So there it is. The next thing is then we need to call logs.printf to print something out, and I'm going to say here gRPC server started on port, and then I want to pass %s. And the value of this would come again from that gRPC port, which we haven't declared yet. And next, if error is equals to, I want to check for a specific error, s.server serve, and on this s.serve, if I'm listening, all right, so this might give me an error. So I'm asking the server to serve using this listener, right? And this might give me an error. And if that is the case, if error is not equals to nil, if that is the case, I just want to call log.fatalf, and in here I'm going to say fail to listen for gRPC, and this would take the error, so a %v, and the error itself is this error. So that is then the function. All we have to do is go back to main.go, and in here where we run the go RPC listen, I'm also going to do a go routine and app.grpc listen. All right. And the last thing is to create a gRPC port. So that the name of that is gRPC port, and it will just get one more 0, and that is it. So that is the complete implementation of gRPC for the logger service. In the next lecture, we're going to call this gRPC from the broker. Let's bring this gRPC section to an end by making sure we are now able to make requests from the broker to this logger service. And what is important is this proto has to be defined in both the broker and the logger, because the gRPC connection is sending and receiving using this proto syntax, and that is the reason this proto file has to live in both places and also has to have all the generated codes. So I can just grab this entire log file, or or I can just get this simple log.proto file and then generate it separately. It doesn't matter. You can do either ways. I'm just going to grab this log file and go inside my broker service and paste it in. So there I have everything. Now, if I open up my terminal and go into cd broker service, all right, and then inside of this logs, I again get this error. So I should install that here. Go get google.golang.org/grpc. So that's one thing. Of course, make sure you are inside the broker service. And also, I want to get the protobuf. So with all of that, the last thing to do would be to go inside CMD of this broker service and there in the handlers. Now, before we had this function log via RPC. This time we want a new function, and I'll clear everything inside this so I can write everything from the ground up. But this time it will be known as log via gRPC. And in this handle submission, right after that log RPC, we want to have log dash gRPC, and this function should then call log via gRPC. And of course, it takes the same payload request. So let's finish it up. Let's go to the log via gRPC function and let's work on this. Now this function should first call the gRPC package and it should try to dial to my gRPC server. So grpc.dial, and it seems that this dial is let's check. Just a moment. Sorry. So let's call this gRPC package again. And on this, we want to create a new client. So a new client connection to the server. And the endpoint would be that logger at 50,001, I believe. Let me check. Let's go to logger service. There's the cmd main.go. And let me just copy it out and paste it back in. All right. And after that, we also should call the gRPC with credentials. So gRPC with transport credentials. And this thing should take the insecure from google.golang.org/grpc/credentials. And they're the new credentials. So just like that. And this is just the syntax of writing it out. So this gives me the connection, and it can also yield an error. So if error is not equals to nil, I want to call app.error.json, and to this I want to pass the w and the error itself, and of course return output. And if I get past that error, I now have a connection which I should differ close when this function ends. So differ this connection, and on that call close. After that, we have a proper connection, and now we need a client that connects to the log service of the server, right? And we actually have this from the generated files right here. So I'm going to create a client variable, and I get this when I enter the logs package, and they're the new service client, log service client. So we have a log service, and for that we have this client, and this takes the connection. And after that, we want to create a context, a timeout context that would automatically time out this request if a certain time is passed. So I'm going to get a context, and I'm also going to get a cancel function. When I try to call the context package, on that context package, I try to create a context with timeout. Now this starts by taking context.background, and the time to take is 5 seconds. So 5 multiplied by time dot second. And right here also I should differ call the cancel function. So with the client and the context at hand, let's create a request to be sent. So request. And this request can be a pointer to our logs, and they're the log request. So this should take a few things. It should take a log entry, and that log entry then takes a pointer to our logs.log. And that log then takes a name, and it also takes a data, right? So what's the name? The name can be found inside the payload. So p.name, and it also takes p.data. So this is what our request is. And now using the client, the context, and the request, we can make the request. So we're going to use the client, and we're going to make a new request. So we want to call this client. And on this client, we need to call write-log. Sorry, we need to call this write-log function, which takes the context, and it takes the request. And at the end, if this is a successful, it generates a response and an error. So if error is not equals to nil, I just want to call this. But in case if we get past that error, we have a proper response, which we can send back to the to the front end. So a payload, let's create a payload. And this payload would be a JSON response. And this takes an error, which is false, because there is no error. And it also takes a message. So for the message, I want to say response, and on that response, I have a result. And then simply call app.writeJSON, and this takes the W, it takes http.statusAccepted, and this payload. So that is then it. So now it is time to test the gRPC connection. Open up your terminal and make sure you are pointed at the root directory, which is Go Distributed Microservices, and first do make down and then make up, and wait for the make up to complete. It takes some time. Next, open up your Postman and you can duplicate this RPC connection and name it to gRPC. And in the body, instead of RPC, use gRPC and send the connection. And we see everything is okay. We have 202 accepted and everything is fine.